bringing retro tech into the modern day.
Welcome everyone. Only took a while. This is lately to spend some hours resetting up everything from scratch just because to test things. So let's continue with our language now that our T2 Linux for all the subscribers and stuff know me already. Otherwise we do T2 freaking Linux, right? But now that this is mostly amazing, although I hope we didn't break something with great refactoring the last days, let's do a programming language. From scratch, totally from scratch. So let's see. Welcome everyone. Hello, hello. Finally, language and microkernels. That was the audience want to see. Still forking Lua. No, we're not forking Lua. I never said we will fork Lua. We will use less. It's totally from scratch. So we started brand new hyperlink install. Nearly everything works except cursors. So completely from scratch. So also we will do this live here, right? Like so Emacs. I prototyped some, I didn't prototype much, so we will do most things live, right? I mostly prototyped stuff. Let's leave that here or stuff. And so entirely from scratch. So the point is I will also make dedicated YouTube. And cursors are cursed. Yeah, exactly. So this will be totally from scratch. We will implement this in some variant of Lua, but we will, with the goal, like only the initial prototyping. Just not to use C and C++, that is too error prone. But we will not reuse anything beside initial prototyping just because that is just the most convenient language to write stuff in. Years ago, I purchased this amazing book for Office Library. If you do compilers, of course, literature like compilers principle is like, hey, my reading mark is there. However, it has been also, sorry that I hit the microphone. Yeah, go get some good standard things. I've only written that 20%, 30%, and that was 10 years ago. When this is 2 years, yeah, okay, whatever. So basically, so we will not go through this book and implement all the theory. I guess the book is also mostly C or whatever. So Wayland, it's overrated. Which one, the book or Wayland? But basically everything. So the point is, if you're wondering what is the point, as a very brief introduction, I've done things for 25 years. I started with Pascal and quickly C++, as it was in the year 2000, 1999. Basically C++ since 1998. Of course, not everything was amazing. Now we have all the new languages, Rust and Vig and stuff. I'm aware of those, and D and F and whatnot, and Swift. The problem, first of all, I don't like Rust for so many reasons. Previous YouTube live streams, right? So like I hope we're live with all the brand new setup here with audio and all the other good stuff. And so I don't like Rust, and the most also the problem is all the stuff is too massive, right? So what I want, so basically 25 years later, lightweight C++, okay, Rust somewhat cursed, not a fan. Lua somewhat amazing, but not the language I want. After Lua 5.1, they made the language strange and stuff that nobody likes it anymore anyway. So 25 years later, nobody made the language I want, plus everything is too freaking large, right? If not only GCC and LVM Clang, but even Rust, like, so if you, or Zig, yes, I'm aware of all of them. I don't want a language that has hundreds of megabytes source code, right? And stuff. Even Rust, if you extract Rust, despite I don't like the syntax, but 4 freaking gigabyte, right? So the point of all of this, also this is basically the wrong website, sorry. We might implement stuff here, like there is not yet something to see. I have a placeholder website for 15 years or whatnot already. So basically nobody has done what I want, and everything these days is too large, right? We had prototyped some stuff. I also made some changes. Where's even my link? So I did previously some stuff, but so nothing is set in stone, right? Like, so this is a totally moving target, and we will do it from scratch starting last weekend. I've so far only brainstormed some stuff, and I have some idea of what I want. So first, I want something tiny. Also, yes, there is TCC, the tiny C stuff. And the problem with TC, first of all, I don't want C. I never liked C. Like basically, even when I was 16, I didn't like C. I was like, who would write such a inconveniently insecure language? But that was a long time ago. And we will mostly base loosely on that. I changed some stuff, right? Also, like most. So the reason is I have the loose idea of I want something as easy to use as Lua. Like I want a language that, first of all, is tiny, right? We should basically. I saw some Python. The irony is some Python mission statement. I saw this just earlier this morning. Because I somewhat prepared to, between reinstalling T2 for testing reasons, I brainstormed. So ironically, the Python mission that I saw somewhere, like maybe on Wikipedia, Python language is somewhat. The irony, I totally like Perl was a complete clusterfuck. Python, but even Python, like. Yes, I understand. There were 1,000 languages, and now we make the 1,001st language. But hear me out, right? We want something minimal, portable, readable, and stuff. And so statically typed, optionally dynamically typed, like we had this recently, right? And with its own Codegen, so we will, of course, not reuse LVM, because that is also hundreds of megabytes. And so we're not targeting the fastest and stuff. And we are targeting the most full-featuredly minimal, readable, maintainable stuff for the Great Reset, also to write a microkernel. We might, or not, we will probably start a microkernel also this year, like the next month, probably in lightweight C++, just to be able to get something started. So the idea is, so it will not be interpreted, it will be compiled with probably built-in JIT support. It is sorta kinder, so it's sorta kinder a mix of that precisely nobody else has done, especially minimal. Sure, LVM can JIT, but it's also massive. Rust, you can only probably, I don't know, can you JIT Rust, but whatever. Yes, we could just use Rust, but what would be the fun in that, right? Also, the language stinks, and the micro-dependency ecosystem stinks even more. Previous YouTube videos. So basically, we try to, yes, I'm aware, I'm not even a language university language theorist, but maybe that's a good thing. So I didn't do, like, I patched Lua, I patched GCC, like you regularly see me fix some things in GCC, but nothing really too major, and so on, right? I hope that's a good thing. Maybe all the languages too theoretically over-designed. I don't know, where was a mission statement? Minimal. Like Python's minimalist solution. Have you, the Python people, minimalist, like, have you seen your language? How can you call this minimalist philosophy? But like, yeah, so basically that, but in actually meaning it, because like, have you seen Python? Very minimal, beautiful, I think I thought it here somewhere. Where was the mission statement? What? Okay, fine. Also, doesn't matter. We should basically come with our. Why did I focus readable, human readable? Also, like Python, really not good. Straight from there, freaking okay. Maybe this was another Python mission statement. Readable, minimal, whatnot. Just wanted to copy the sen of Python. Here's why it has dedicated. You freaking kidding? Okay, that is freaking a little bit long. I thought something shorter this morning. I saw that one here in the let's I hope copy and paste works. Let's just copy some statements here, and what did I press? No, so much to a new installation, and some details still suck. Yes, I have dot files in YOLO, but so what was our somehow a week on non-US keyboard layout. I tell you. So, like basically minimal readable. I also don't have a name yet, but who cares about the name, right? Like minimal, simple. What, I don't know. Minimal, simple. Also, like no surprises or and I don't know, something. Also, I think I need to zoom that slightly. This primary use case is embedded scripting. Which one? Turbo Pascal? How it does the size matters in maintainability, because like I don't like, who should even, how many hundred developers do you want to need to maintain your language, right? The size matters in complexity, bugs, and so on. Not only about embedding, like basically even for I see this daily, right? I compile the open source world. I want basically a great reset ecosystem where everything is minimal. Like these days, we somehow supersize everything. So the size matters. In like 20 years ago, you could run state-of-the-art stuff on an Athlon. Now you need a 1750X just for the background noise and compiling something, right? Size matters in that humans are able to understand it and fix bugs and so on, right? And that you don't need like a cluster to continue integration tests. Rule of thumb is not to write another program. Yeah, sure. I've not written a new programming language, but also like no surprises or surprises undefined. Heavy here, whatever typos. And actually, what was it? Portability. The size also matters. That also complexity. What? Portability or do we have simplicity? Minimal. I don't know. Simplicity. The size also matters. That I really hate that upstream deletes stuff faster than people can maintain. So it matters that if it's so huge of what you need to implement and maintain, then people drop DEC alpha support, they drop Itanium support. In Linux kernel, they first dropped early Spark support. Now they drop 46 support. I want a language there where you can port the code, like reasonable, usable code gen, like in a month or stuff, and not in a year. So the rule of thumb for single language level innovation hasn't. Yeah. Also, like somehow, the languages are also all so similar in a way. But anyway, so let's get started. So this was just some prototyping earlier, right? So how do we best present that? So I have that, like maybe we move that here. And so did I maybe? Okay. We use my patched Lua version to run the code. It's probably, so that is just the code we write. Like basically we could write this. So basically we could bootstrap in C. That totally sucks. C++ and stuff. I want something closer to Lua for that humans, because the thing is with C, C++, Rust, Zig, normal programmers, kids and students cannot instantly get started, right? The language is so complicated that writing somewhat halfway decent code. That would basically the goal of the language. The goal would be, my dream goal would be like truly minimal, not adding every feature like Rust and C++. Basically some Lua like more C-like type Lua language that still is minimal, beautifully maintainable, and also be able to normal people, like basically as a Python replacement. I wonder anyway, also like that also why size matters. Like ideally I would want one language to be useful for beginners and intermediate users like Python, and still have optional low-level typing that you can write low-level crypto and OS code with it, and also use a reasonable subset on a microcontroller, right? Like there's MicroPython and stuff, or like TCC, right? And sure, there will be modules eventually by others, like modules and libraries and stuff. But also, in my opinion, more stuff should be in optional modules and libraries, and not like in Rust. And have you seen the C++? What the C++ library became? So anyway, let's get more started. Let's basically, I was like, of course, I initially instantly need to justify why we do this. I prototyped some stuff here. This is I don't even remember what object, so this is some stuff old. So this is this is just some 100 lines of code. Like basically we start off of nothing. This is just the most minimal start to parse some stuff. So, but what we need is we need to lex the sources. We need to create some abstract syntax tree. We need to codegen, right? Like basically we need to do everything. We will not reuse anything except Lua 5.1 patched a little bit nicely to run this code, right? Like, so this is patched Lua 5.1 code. The function is fn, local is let, and what else? Error is probably throw. Try. What was it in Lua? Whatever. It bitops is patched in. What even was the bloody, so it is pcall, protected call. Pcall is try and so on, right? But basically it doesn't matter. Like basically it's readable code. Yeah. And we will replace this as soon as we have some, like in some 6 months, or like as soon as we have some functional stuff here in whatever 6 or 12 months. We will switch to our own language anyway to make bootstrapping even harder. So what you need to do to parse a language, like I have here, this is what I have, this test. I have here some minimal test things. So test new, I don't have a new. So basically this is like, so what you need to do to implement a language is parse all the stuff, right? So the first thing is a parser. The parser reads you all those byte characters, like ty, p, and stuff, and breaks this up into tokens. And also what I will use to design the language is also what is easy to implement, right? That is why I now need, like after some months of thinking of how do I really want that. For example, initially I thought I do this the new Rust and Circ way of like basically this is untimed and then like int. But in my opinion, this is strangely, my brain can somehow make maybe too long C. So basically a lot of this stuff will be, sure, what do I like, but what is also easy to parse. Initially I had the return here at the end. I somehow don't like it. I was like to me it's also strange. Like basically to parse this, it's not easier to parse stuff like this or whatever. What is it? Rust like this or whatever. It's basically not helping me parsing this stuff. I'm also not yet, so nothing is set in stone, right? Like whatever we find is usable, we will use. So what we also like, so initially I wanted to start with Lua like Lua 5.1 like, but after some prototyping and brainstorming, I came to the conclusion that initially we need to make our lives easy. So initially, like basically static typing easy, because dynamically typing like Lua like table types and stuff, of course, more implementation stuff. So to get stuff bootstrapped, static typing, explicit static typing much easier anyway, because like then you know what you have, in my opinion so far. And later I said this the other video that you see something. We probably should write some specification of what we are targeting, so people other people know what we're after. I had here this new link thing. Can we, like, what happens if we Lua mode that? Does it highlight somewhat? Maybe not, because nah. Also, like maybe we need to turn on syntax highlighting again in this. Okay, yeah, it's not Lua enough. So this is even the old example. I didn't change. Like, did I not save that? Do I have this on some other system? Okay, that's currently not really what we target. Actually, I probably didn't change all this stuff. So basically, I changed my mind. So basically, that would be similar to how Rust has that, and so on. Like basically, I changed my mind to I rather want the type first. It's not the most important. You can of course cause Parse either, but like I like that more, right? Like for me, especially as we explicitly type anyway, I find this more intuitive. And then I set the other live stream. It's like also like U16 or what like that. Adjust here and we're signed 16. This is just some random stuff here for illustration purposes only, right? And because then we have this let-in stuff, so I also have thrown that away here. So this was from our initial, what do we have here, string stuff. Because for me, it is like the programmer experience. Maybe I should sometimes look at the comments. Basically, why both fn and int should be familiar, right? Fn only for the parser, that the parser instantly knows it's a function. That is not yet set in stone. This is only because modern languages do it like this. And for example, so I will also do away with this let. I said this in another live stream. I might not have saved that, or it's on some other system. But basically, so initially I wanted let and stuff, similar like basically to normal for normal programmers like Python and Lua. But I set this already earlier in another live stream. So basically my current idea is that, because like also like it's less typing, right? Like you need to constantly type colons, like because for me it became too annoying. Like basically this modern languages, colons everywhere. Some of the modern languages like Rust and Vic, I find on at least Rust. Have you ever written a language or something similar before? Who do you write? You need to like, do you chat with each other? I have not written a complete language. Like basically 25 years later, the languages become worse and worse and bigger. And like, I now take the language design. Like, have the Rust programmer written a language before? Probably not. So my goal is to have Codegen quickly. So basically that is like, basically this is less typing, right? Like it's basically in space stuff instead of blah, 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 colon. So something of that sort, right? Like nothing here is, this is all currently prototyping, so, or arcs, whatever. So that's basically, that is why I toyed with the idea for some months, and that's basically after thinking and testing and stuff what I came up with. So also this let stuff is annoying, because like basically why type this let stuff when you can type a type, right? Like why otherwise let stuff like let name string or whatnot, like this is like why make it, why do modern language designers make languages so shitty? I don't understand this. So do you like PHP? Of course not. So what do we have here? String. What do we have here? String. Like and so instead of let and stuff, like so initially I thought like okay, let's do let. But basically because I came to the conclusion that I want strings or like standard string or whatever here, or YOLO something, time will show. But given that, what do we have here? Standard string, what do you have here even? So instead of let, like basically instead of like this let is just typing more stuff for nothing, right? And that is why I said this the other live stream, I will probably internally, the language will internally have some auto type, which will be some Lua kind of box thing, but that is for another day, right? Okay, let's save this. So that's basically just a quick summary. So let's get started. Like basically what we do is I want to practically, like practical hands-on, like not computer science theory of graphs and complicated whatnot generators and YOLO. My type star, my var, is that declaration or multiplication? It doesn't have an assignment, right? Like basically, if it doesn't have, I find columns based here. So I don't like this colon. I don't like this colon. Yes, I grew up with Pascal. I've not touched colon equals. The reason for let var is because they have arbitrary order declarations. It's annoying to figure out if you are actually looking at a var declaration or not, because you don't have all type names yet. I mean, it works for C and C++, right? We will see. So I want to grow this because we need our own code gen. We will not even bother wasting our time with interfacing with LVM. I looked up the LVMIR last weekend, and oh my god, is it complex? Exactly this. I mean, we will see how. I mean, so fear basically. I need. Okay, so of course it would help if we would do some language theory, but I learned already in university a long time ago that most people are not into theory. Of course, it theoretically theory would help of actually making some design documents and so on. But nah, that's too boring, right? You always know if you are looking at a type. No, C++ does not have entry order decode. Does not have arbitrary order decode. There is always a sample table. Okay, so but anyway, so I would prefer if we don't need let and var and stuff. So that, in my opinion, that is more readable. Basically, I want also a more readable language than Rust. So you will be generating assembly from scratch, or how will it work? Yes, of course. So let's do that stuff. So the idea is so. Let's do some more stuff. Like if we only talk here about other languages, then we never get something done. So I started here with parsing this stuff. So that is extremely simple garbage code. So basically skipping on symbols and spaces and stuff and poor man's token stuff to get here started with something. Let's use our Lua interpreter. So Lua. Parser 2 and put in here. So this is basically next to nothing, right? Ideally, sure, I could sit in some corner and write a language from scratch in the basement, but you want to see all the stuff, right? So test new. Why does this do nothing? Lua, because it compiled that. Now we have here probably some random file. Lua C out. And I already want to see this slightly better. Do I have native copy and paste? You want to see that slightly better on my 16 by 10 screen. So let's tmark that. Chit stuff. And why does it attempt to call a null 268? Not sure what I left in there. I thought this was working. What even was temporary? It's been some time. It sucks a little bit. All right, maybe I have here this. All right, this one here. That is that stuff. Oh wait. Yeah. This is probably that stuff here. Good. That's better. So I basically did this on the train ride some days ago. What you do, right? Otherwise, I would have live streamed it. So this does next to nothing. This is only some lure and other right for the string stream. Okay, I copied the string stream stuff from one of our other code things here. So it's basically just a C++ like string stream for getting characters. Here's some spacing, so that's extremely poor man. Like this is basically Lua with some things renamed to get in the spirit of where I want to go with our language. As this would just. I did this because I don't like. Basically, for me, Lua is dead. Like after Lua 5.1, like basically Lua's it's hopeless. And then I thought, like, if Lua is already hopeless, let's move with our internal Lua code base. Let's move a little bit into the direction where we really want to go. This is why I just recently, the last month, patched our Lua to let and throw and try and stuff, right? And function to fn. So that's basically make Lua 5.1. Like maybe I should actually release this as rebranded Lua, like maybe because most people like Lua 5.1 anyway. So what do we have here? Well, because our current language sucks, like that one is easy. Yeah, exactly. Okay, so handle. So this is skipping over stuff I most poor man's comment handling, like basically if they're like poor man's preprocessor, if there's a comma like skips the stuff, get one character here, gets the next token here, break on space or whatnot. So this is extremely simple. You will see more of this stuff, like basically pass. I have here basically just a little bit toying, right? Like basically pass function, like basically here's the main thing, like for next token and then decide what to do. So basically this is from scratch, like it's just like one train ride of like toying. And here's just some comments of what we want to generate. So instead of implementing here half as a language, so far this parses like poor man's garbage code, and basically we still need to do everything, right? Like exactly how you want it. So this is just like on fn. This is why currently it's easier. Maybe we eventually get rid of this. We will see is this fn or not, and so on. So what I would suggest now, what we do is, because we need our own code gen, start code gen. Basically from the other. So basically this is tokenizing the stuff. So I can currently tokenize this with this 100 lines of Lua code. And this is also why we implement this in Lua, right? Like this stuff usually doesn't crash. And we can just spit out strings and byte sequences and so on, right? So currently we can't pass this thing. It doesn't do anything yet. Like basically we need to store this. This is also why Lua is handy. Lua 5.1, we will throw all our types into some table and have some nice, relatively performant string lookup and stuff, right? So we can pass this. Currently we cannot do much with that, but we can tokenize and somewhat pass it, right? Do I, if all, is it even true? All right, all right. So of course, we currently do not build in, like basically we still need to do everything. We do not even build in syntax tree. So for code gen, my idea is that I wanted some LLVM like intermediate language. We will probably generate like from this high level language, which mostly shouldn't care about endianness and stuff. We will generate LLVM-like intermediate representation and JIT-Z. And the idea, this is why I prototyped here some stuff. I have here other examples from years ago, but we will mostly not use it and do. I have some here. Probably some. Okay, this is just some. Anyway, does also not matter. Like basically, RISC-V is that stuff. Let's maybe better here some RISC-V either. Base either document thing. Okay, this is a super new install always offer. Like no, like why is that even like should we patch that away in T2? Yeah, whatever. Just give me some. This is a brand new T2 install. So ratified specifications. Unprivileged either. So we want to code gen, right? So this is RISC-V. We looked into the details some previous video. If you're new to my videos, we did a ISA walk down some years ago. YouTube. This is so new, of course. I didn't even visit YouTube. Installed it today. JIT. Any alternative fixing mode? So sorry. Sorry, I misspoke. We wanted code gen, and this code. So yes, it will be simply compilable ahead of time. It will support both, but we will write the code gen with. Yeah, I somewhat misspoke loosely of what I meant is just in time generate this code. So the goal of the language. So it will be simply ahead of time compilable with our own code gen backend. We should just from the beginning write the code gen backend so that it supports JIT just in time into memory and direct execution. And I would like to have this JIT properties in the language in such a way, we will probably see next year, that you can JIT like basically like Lisp or other Lua things, that functions are first class supported things, and you can have functions at runtime and JIT this at runtime. So basically that unless there is some very basic super minimal mode for like a microcontroller that like in a normal use case, you can just JIT code in like native language JIT code, like you can native dynamically write new language in Python and Lua and stuff. So the codegen will be language, like language to some IR, and then to, yes, in our assembler, like to our JIT thing, yes. And so the goal is like to keep everything, like we will initially make everything the most simplest possible, and like only extend minimal thing if really necessary for some feature. So there is bytecode VM Java. So probably with the bytecode we need to see, like, so initially there will be no there will not be bytecode and there will not be an interpreter. I figured that years ago. Interpreter is just more code that you need to write, and bytecode just like, sure, it is reasonable for some things like Java or Lua. The question is some random thing suitable? I would need to look into the details, and basically reviewing others people's code and stuff just takes so much time that if I review everything, I get nothing done, right? So RISC-V, so that is, let's see here, RISC-V. Either we had here some walkthrough. You probably want to, I was like, why is it not me? Also maybe because there is some typo. Maybe that one or others. So, but let's get stuff done. So, basically, what I suggest we do, we currently can tokenize, like this is, how many lines is it even? Was it by the way not Control L, switch to buffer? Control L is switch to buffer. What was go to line? I used too many editors. I used G, of course. Matter G. Buffer already active. Wonderful. G, of course. That works. Okay, beautiful. So I would suggest we next implement parsing here assignments and functions, and be hopefully ASAP able to generate code. Like so. My suggestion is we write the first test function to JIT. Like so, basically, I was like in. Oh, this is actually relatively well positioned. Amazing. My brand new OBS setup. Let's see what's going on here in notifications. Okay, nothing important, only notification overload. So, to this practical guide to writing a new language from scratch, I would suggest, this is probably everything. I also, wait, what? Oh, that is, okay, that is actually the wrong language. That is checking stuff out. No, we have that actually. Yeah, brand new installation. Oh wait, I did this wrong. I meant CUTF-8. So, okay, I close this. Of course, I close this. I also should put this into some public repositories and soon for others to help implementing stuff. Tmux in here. So let's copy this test new. Let's maybe make some test folder. Tests and move test new to oops, that's what I did. Test to tests. Test new and tests to maybe that is where usually CD. So just one function. So I would suggest we did I put some, okay, currently just put some switching between VI and XEMAX. But JIT, you need that. The nice thing about bytecode VM is that you don't need 100 compiler. So you need to compile backends anyway, right? Like the thing about bytecode VM, unless you have an interpreter, but basically interpreter so low performance that I wouldn't bother. I rather would want something where I can implement the Codegen in a weekend or two than like with just like a low performance minimal working thing than an interpreter, because like interpreter you need to have another code thing written. Yeah, certainly eventually to JIT common like non-enginous aware code. Why not if you don't have a compiler backend? Yeah, but which one? No, it's still an interpreter. Like if you switch on bytecode opcode thing, do things, it's an interpreter. Like even if it's a like if you don't have Codegen, it's an interpreter, I would say. Okay, so we want one test function that basically jits the stuff. Like basically, let's take some int things here and just add them. So like the most minimal thing, right? To toy around here with Codegen. So return. So that is what I want to be able to pass. It's like a return a plus b, right? Like let's make that work as soon as possible. Interpreters can be reasonable fast, but other of course there's a difference. Sure, there's a basic like or whatnot. There is a difference between source code interpreter, like direct source code, and compiling to bytecode and interpreter. Sure, but it's still an interpreter. You have Codegen, but only to your own ISER. Well, you will still need this portable C or whatnot interpreter. Is there any command given a TLDR? Not really. And welcome everyone new to this channel. Wait, why is this so strange? Third-party events. Oh, this is why. And thanks for all the new subscribers and subscriptions. So, what we need for this is a function. We need to generate function, prologue, epilogue. That is the housekeeping stuff of calling a function. Let's initially use C-like calling ABI, just that we can mix this code for testing purposes. And so basically that is relatively little. Calling us like, okay, we need both ins here. That is relatively just to get some readable infrastructure build. Okay, I see most people features. I see as with every language, you need to start with a website. Basically, I summarized this already. Basically, I want a yeah, we probably should put here some website up. As much as I hate it, then people accuse me like, yeah, you vape. Sure, for years I talk language now, but hey, now we're really doing it, right? Like now that our Linux is amazing, we finally do language and microkernel. But then people like, you make a website. I didn't even make a website except buying this domain some years ago when I could, just to have vmkit.com, and have this placeholder here. But so basically more readable, like truly minimal, more C-like, more Lua-like C, and more readable and extremely minimal yet high performance, like more minimal than 4 GB of Rust compiler, LVM, and all the, like if you take the Rust compiler vendor source thing and extract it, it's 4 freaking gigabyte. I'm targeting more like 40, like something reasonable, like 40 megabyte for some language compiler thing, and Codegen for reasonable architecture should be enough, right? Okay, this is currently, I wanted to show some further design decisions. So this is currently my work in progress thing here, right? We can also, all right, I just renamed that. That was very clever. Yeah. So for example, in C, so this is minimal stuff, but so similar to Lua, this parentheses here will be optional, because like, so of course they are optional, because like I don't quite understand the C thing of needing parentheses there. So basically, it's also a typing, like typing friendly, not cluttering stuff all over the place. Another thing, I'm not yet 100% sure if I want this curly parenthesis here, but initially we will go for that. If we go for that, like we could make, the thing is, maybe we go for that to make that like code blocks of some sort, and you need them here for if then else stuff anyway, right? So I'm not 100% sure. In a way, if you have a function like, so the Lua way would be this, right? Initially I liked that, but most people are so used to curly braces anyway. And then you have the thing of, if you need curly braces, like if we say, okay, we would support it like this, without this explicit curly, like this is how Lua does it. Then you have nothing for if you need like native code block things. There is even, I think Lua would have that like that, right? And this is why I currently, it's a little bit typing. The only thing is, should we support, the irony is like for C, like for C is so strange, right? Like C enforces parentheses here for arbitrary reasons. Or maybe I should read the C standard. But then this scopes here are optional, right? Like this is, I'm not yet 100% sure if we should, like some people would argue, like the irony is like this block scope thing here, whatever precisely that is called in C, is optional, but most modern people is like enforce it anyway for avoiding bugs, right? We will see. In a way, it's also easier for the parser if like you need to have some code block scope thing there, then you need to have it there, but we will see. This kind of stuff, it's not set in stone. Like this is basically after some months of trying around. I'm also not yet 100% sure what I do here with this question mark, or what is it called in C? This question mark operator thing. What is it called? Operator name here in what even is the? Can we? What even is someone help me? Just call this question, like, why is this? Oh, this is why is this in freaking German? I didn't want. I want freaking English. Change to English. Why does it give me German things? What name does it have? Ah, YOLO. Ternary, if operator, something. I'm not yet really sure how I want to support that, you all. This is not the highest priority. I played in a way. I don't know. Does Rust even support that? I'm not yet so sure. I tested here around. Did we even? YOLO. Does. Yeah, whatever. Not the most important. To be fair. So let's get some most minimal. So we wanted to Codegen that. So what do we need to for that minimal example? The most minimal stuff of our future language. Also, in my opinion, semicolon should be somewhat mostly optional. We will see. Initially I hated this in Lua, and like it's basically sure everything in Lua. Like when I was new to Lua 15 years ago, I was like, nah, it's so cursed. Like end and yeah, but basically that is like make life for programmer easy and not like constantly need to type special characters and keep. So currently that is what I'm settled on. Like if people have more suggestions, let me know, and send patches and stuff. And we might change this. Like if something is too annoying, like basically the philosophy of the language should be like, if it's difficult to implement, make it simpler, right? Just basically everything, keep it stupid, simple, and not simpler. Okay, so for this we need to so basically parsing means like tokenizing stuff, right, on spaces or other special characters. So we would get fn, we would get int, we would get test, we could get here the parentheses. Ironically, even those could kind of be sort of optional, to be fair, right? So I like some things, like for the parser doesn't need that here, right? If we like basically, and that is also like, now that I implement the language from scratch, I realize like how much over-defined other languages are. Even like fn. So to be fair, in C, you basically need this for like, what should it be? Like basically in C++, it is like, okay, if you have parentheses here, like then this is a function declaration, right? But in Rust, you have fn here, right? Or other languages. And then this here actually becomes superfluous, right? I keep this in the language currently. Like basically, it's only extra work for our parser to skip this. Like this would be otherwise completely fine, right? Here's some like fn type, function name, and I mean, sure, what is a function name if you have in whatnot multi like. I'm not saying my language will support this, but let's say we have here unsigned in, like where does the function name start, right? But so we will, but it's a little bit over defined, but it is what it is. I mostly keep this here for readability, that beside type name, where does type name start and end and stuff. But if you do your own language, nothing is set in stone. Just because C or A or Modula or Argol or Fortran did something like that 60 years ago doesn't mean we does need to do it like let function name, yeah, let fn, let yeah. Mick broken? I hope not. Why do you say Mick broken? Twitch had a stroke, sorry. I have 0 drop frames, so I don't know. Okay, also copy. Which ones? I mean, as this is a brand new setup, maybe that's a noise suppression. Twitch dropper. Okay, what? Like, I could actually. The only thing is if I background. Actually, I don't have an audio delay. Like, I need to reset an audio. Anyway, so this is the most. I mean, okay, the most minimal stuff would be to do nothing. But where would be the fun in that, right? So for that, like, so basically, what our parser see, I can so much is already working. So much, one train drive. Okay, here somewhere. Let's dot. So this is our, so we only use a Lua interpreter thing, compiler interpreter for bootstrapping, right? We will do away, we will reuse nothing. And that is the code we parser 2. This is parser 2 because my parser 1 is actually a C-like parser, right? But that is for another day. So this is why this currently we need some name for our language, but that is we also need to make this a class and stuff, but this is basically we can like basically, so where do we have, if you want to see, okay, so this currently doesn't do much, right? Like this token only tokens on some special characters and returns it in between. We could probably make this more beautiful and more simple. And then basically this is the main loop. We will need more, like this is the most minimal skeleton, right? So now we need to implement more. So for example, if fn, like if this next token, like in my prototyping, everything will be a string, like Lua, like do stuff in strings and tables. Can't do multi-line, otherwise it shows in 8f. What you're saying? I can't do multi-line, otherwise it show an if. Which if? What do you mean if sometimes? What do you mean? So basically, if I run this, you still mostly see what do I? So this is. Oh wait, this is not what I wanted. I wanted tests. what I call this fn. So basically one function. So that's basically what we get here. That is still, so it's printf based, print based debugging. So let's see my cursor recon problem here, especially in the new hyperlink setup. So that is the main token thing. This is just how I print this here. So fn. So then this is from parsing a function. We will soon remove that. Then it's parsing here the arguments. This is currently not yet let used. So now we need to implement all the stuff, right? Implementing all the stuff means some table of types. Initially, we will just use a Lua associative array table thing, throw our string types in there, right? Until we need more. Like basically keep everything as simple as possible and readable and more maintainable than TCC, the tiny C generator, right? So next we need to actually parse it. Like, so this function arguments are not yet passed. I left this for us here to do together. And then here, this is basically parse. This is a printout of my printf, like parse and any body thing, like because we need any body of generating some kind of tree structure of the code. Yeah, so these are just the tokens, and from this we need to generate code, right? So what we need to do next is build some kind of abstract syntax tree, here in Wikipedia. So you don't need to buy books. You can just read probably some kind of Wikipedia things, right? Like, of course, as I said, I have here some book that I years ago somewhat read. Also old book and YOLO. So what that means is some kind of abstract tree representing the code. That means bringing this in some kind of form. I think I will go with SSA single. What was SSA? Wikipedia, or is it even SSA for single static assignment form here, or SSA single static? That is a new representation single. A newer compiler theory thing of every, like basically simplifying like other people's university research from decades ago, of efficient algorithms representing converting programs in and working on that. The thing is that every temporary variable is only assigned, like everything is const, like internally in this single assignment, static single assignment form. Even if you assign a your var in your code multiple times, it will create new temporaries. So if you have a var x and you constantly like some algorithm x plus 1, x plus a, x multiplier, so it will never reassign that. It will always create a new temporary. The benefit of that is this research decades ago made compiler infrastructure easier, theory better, to algorithms easier to work with, and so on, because a lot of things become obvious. If you don't have the single assignment form, and GCC initially hasn't, GCC probably converted to SSA in maybe GCC 4, 15-ish years ago. The benefit is that dead code and dead assignment and unused code and stuff is much easier to analyze by gradually removing stuff that's not used in the end, right? If you don't have the static assignment form and vars are recurrently reassigned, it's more difficult to work with it. Are you just writing it for the journey or distinction? Are you writing it for the journey? No, I write this because I see that I don't like the computing future that I see. Sure, AI will take everything over, YOLO, 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 but if we can still improve stuff before AI takes everything over, I don't want to work with Rust, I don't want to work with Zig, and I want tiny Codegen. Like basically, like everything becomes too complex. Like basically, I also want a microkernel, but we need to start somewhere, right? Like basically, I see Redux as like basically everything I see is meh. Sure, our language will also be meh. Like basically, it is also in my company we use we switched some things to Lua 5.1 10 years ago, and then we did not expect that the Lua people ruin Lua. In my opinion, Lua after 5.1 not every year became worse. And the thing, I like Lua 5, like many people, like many even Lua JIT and game developers stuck with, like, am I the only one who says everything after Lua 5.1 sucks? No, other people agree, and most people just stuck with go. Have you? No, go. I was like, okay, stop other languages. I don't like them. Okay, so let's finally make a language that I like. Maybe you like it too. So, if we let's to show you where we need to go. So what we need to do next is do the Codegen. So internally, we will we have two main options. Of course, we have infinite options, but we have two main options for our internal Codegen. So this will be somewhat our internal. Like I just brainstormed here some things. This kind of will what our internal code look like, right? If we go to actually, maybe I shouldn't have closed it. That was not ideal. Like maybe we should have kept this open. Let me just rebring. I probably should have a saved bookmark thing of things we need to recently closed tabs of that, and history recently closed tabs that would actually be pretty smart to keep around. So the problem with Codegen is that we have mostly complex and risk reduced instruction set things, right? For all the things, previous videos on YouTube, I've shown a few. The main thing, like if we x86 assembler, so the problem is, of course, that they are all vastly different. Of course, other people have unified some stuff. There is GNU Lightning, there's other JIT stuff, like GNU Lightning, LVM and stuff. And I will optimize for RISC, because RISC is the future and amazing and stuff, we all know that. And make and maps that also to x86. So to make this easier, I will probably at least initially constrain this stuff to two operand true, like load store, RISC load store, as in not like x86 where we can memory references. So that is every memory stuff we need to access, we need to load. Probably like LVM does it. I don't. Some details might sometimes be off. I cannot look into every detail, because most CPUs do it like that anyway. So we do load, we do compute stuff, we do store. Then the next thing is our two main things is we have 3 operand and 2 operand things. x86 is 2 operand, meaning you add, if you add something, add long here, add L, intermediate thing 24 to ESP, for example. That is a bad example though. Add yeah, go. Basically any other thing like add and multiply and stuff. You usually only have 2 registers, and that might also be the case for certainly there will be some RISC architectures. The problem is that other or many RISC architectures allow have 3 operands. Wait, why does it not? Why did this? Okay, this was hanging a second. Let's go here to any. Do we have? Can we? Why does this not browse index? Why is this always so? Nah. If you want to quickly, don't. Why does this not work? I want to just give me some bloody extraction. Maybe I need a proper PDF viewer. So they also changed this. I think they previously looked different. Come on, where are the definitions? So this are the registers, right? RISC-V says 32 registers with the first is 0. Our internal representation will probably use something like that. And for the Codegen, we probably will have some global, like this architecture has so many registers, like general purpose registers, and simply only generate as many, right? So x86 as AMD64 would be 16 minus those who aren't usable. RISC-V would be 32 minus 1, like 30, 31 and minus some, we will see. So here are the destinations. So RISC-V, like many others, they have usually destination and 2 source registers. And like initially, I will simply assume the destination and source 1 are always the same. This is of course not ideal. And maybe later, in a year or two, when we actually really use our stuff and we get more ones, we could have like we could have multiple global config things. We could also comment that here already for like global nrex and global 2 operands or 3 stuff, right? That's also the problem with portable bytecode, because if you try to map, so basically, let's use the minimal common denominator initially, and then let's see what we need additionally for high performance. Also, so throughs would not align, and you would need to look up which instructions take 3. Now, the problem is if we internally generate always 3, it would map to many RISC architectures, but it would be extremely difficult to generate this for x86, because x86 usually only has 2, unless maybe FMA3 or whatnot. But then you would always need to load temporaries, like you would always like spill stuff and load and store and stuff. So that is why I rather de-optimize RISC a little bit of being able to map this RISC, like basically some least common denominator RISC-like thing, like true load store, like basically make life for RISC easy and make life for mapping that to x86 easier. And if we need more, like basically keep stuff stupidly minimal, and if we need more performance later for reasons, we can still improve that, right? So that would be the initial goal. Just to summarize, like what are we working with? And then all the RISC architectures are nearly the same, like nearly the same except Spark register windows, like all the MIPS, Spark PowerPC, sure. The encoding is difficult, and some like, they usually have a handful of registers, 1632, 0 is often 0, usually 3 operand. Sure, test compare stuff is difficult, different in flex and stuff. Like eFlex, like Alpha does not have some flex and so on, right? Basically, we need to peephole generate some custom instructions for some architectures. I think that should be relatively easy possible. Why don't you start with IL and write just the compiler to RISC-V? Because we don't need. So we keep something stupid. Sure, I could write down some text file of IL things, but then we would need to pass it anyway. Sure, we could do that, but we also don't really need to. But thank you for the suggestion. Don't have to care about real world either, register allocation and all this stuff. Very inefficient if you want to make the compiler unified architecture. Well, so the compiler frontend doesn't care. It's only the intermediate representation. And we will see how often we really need that. Again, we probably could easily, like if we set some global of like 3 operand thing or 2, we could probably easily, like in the Codegen, like in the intermediate representation to Codegen pass, we could probably easily support both, but I will first keep it simple and then see what kind of code we generate. And that's probably an easy thing, but that's famous last words. I first want this minimal stuff working, and then implement some architectures, RISC-V, PowerPC, x86, and then add from there and see how complex stuff becomes, what more we need. Yeah, that's the question. I mean, sure. So only benefit, like the question is, what does the hardware do? Like, does out of order speculating hardware probably doesn't like it very much if we always clobber the destination. And then, of course, we always destroy the one source argument if we always source like S1 plus S2. If we always clobber one source, yeah, it's probably not the deal. Wrote JIT for x86 some time ago from scratch without any optimization levels. Found that it's 180 times faster than Vladimir's Mir and infinite plus times faster. Everything else that was fun. Yeah, exactly. Let's see how fast we can get stuff. What do we want to go? So basically, we don't need much, right? Like basically, what the RISC-V calling convention, RISC-V calling convention. So you always have like arguments on registers, of course, unless it's more than 8 or whatnot. And you have that here, bytes and RV calling convention. So RISC-V calling convention. So calling convention is like how are arguments passed to functions. So all RISC architectures usually name the 32 or stuff like the numerated registers also with some nice assembly friendly names. For example, A0 to A7, so that you have 8 argument registers. And other stuff is then saved, spilled to the stack. The hardest part was incredibly bad x86 encoding at Parse. Yeah, yes. So as you see here, so these are registers. So these are the registers. So that is 0. So return address, stack pointer. So that is why how this is similar to all the RISC architectures, right? Just every little bit different. And so that's this return address. Like this is just a number from 0 to 31, and then we have here function arguments, return values. And that is kind of stuff. We will have tables for each architecture. Our backend will have tables of like similar to LVM. These are the argument registers that return and so on, right? Function arguments, return values, A0 and stuff. Function arguments, return values. Not really sure, whatever. Saved registers, temporaries, thread, local pointer, more temporaries, RT, temporaries. I don't know why they have split it like this, but maybe because they planned for the 16-bit 2-byte compressed encoding, and you probably only have half the register. That's probably why they probably have some. If you're wondering why stuff sometimes so strange, because they optimized for some compressed encoding and stuff, like to have 2 temporaries there. So what we need to, so we basically need to use A1. So probably internally we will see how we do this internally. We will probably internally mostly use numbers. Maybe we implement support for this human readable register things just to print stuff, like pretty print stuff nicer. We will see. So all we need to go, we get for implement our first most trivial function. All we need to do is add those, like basically add A0 destination, A0, A1, right? And then return. That probably should be enough. We can pre-test that. Let's turn on our T2 build server. Let's actually quickly write that in C and assemble it to RISC-V. Oops. If I could type. So that's just my build server. Let's do this in C. So test C. So int. You see that there. Int test or whatnot in A and B. For this case, my language actually will look identical to C. Let's see how long that will be. Return A plus B. Here we need a semicolon. So for this travel example, it will be identical. Then I hope I have a RISC-V build. Famous last words. Let's take GCC, RISC-V 64, GCC, and assemble that to standard out, test C. Oh, that is bad. So that is crazy, but that's also because it's not optimized. And if we optimized, oh wait, I did this wrong. So optimized it is. So here's our test function. Why do I have -s here? Assembly. So what is crazy is, and that's also kind of sorter what I don't quite understand. I hope in the medium term our project could not only be hugely successful, hopefully, obviously, but I never understood this with GCC. To me, it is crazy that GCC, like unoptimized, like if how can GCC? I understand. I understand like unoptimized, like it's load store, but how? I would hope in the long term that our language could actually be vastly, in some ways, better than GCC or whatnot, because I don't understand how for this simple function it can generate that much assembly code. Unoptimized, I understand with complex code. With complex code, I would understand, like complex structures, volatile, thread local, and whatnot. Okay. But hear me out. That a compiler, like, what does it even? So that is that a compiler generates that much code to me is just crazy. I also don't quite like why does it allocate stack space? Like it somehow manages. For this simple, like, I don't understand. That is where I would hope, like, that our language, like, even implemented from scratch, wouldn't have that much worse performance. Like, hey, also, why is GCC? Imagine how slow GCC is, like, generating this convoluted stuff from every function and then having to optimize it away. That's just crazy. Anyway. Of course, if you optimize this, probably with, I had here 01, probably 01 is already better. So I don't understand, like with all my understanding, I patched GCC for 25 years. I've seen GCC, I've worked with GCC, but I don't understand how you can write a compiler that internally, initially generates that much code for a function. I really don't understand. Maybe we will end like famous last words and we will end with the same things, but I remember the story of two business partners. He works it into what the heck is it even moving? Yeah, probably frame pointer and whatnot. Anyway, so that is all we want, right? This is exactly what I told you. This is exactly what I told you we need. So let's see, how hard can it be to generate that little, I mean, all the surrounding, like how much, so, okay, this is just comments of like, the file is test C, the options are no pick. These are the RISC-V default attributes here of extensions, RV64 and stuff, underlined access. I would see my mouse cursor and this is hilariously small, world's smallest pointer again. Align, global, like basically align, you're like, yeah, comments, so much type test function, wonderful. Okay, also like CFI Codegen function. What did that stand for? Let's learn something. CFI, what CFI in, like what precisely does it, right? CFI, what precisely does it even? I've seen this 100 times, but never. If you live talk about this, what does it even mean? C function information, whatever. I don't know. Okay, so that's what. Okay, that's what all the stuff does, like telling the assembler and linker and stuff. Like, hey, we have here global test thing. That's type function. Here is that label, the symbol. That's all we wanted. This is so much over. Like, why is shit slow? The great reset. I understand you need alignment information. You need like yes. Okay, fine. Good. Also, size of the thing is test minus test. Like where is even testers? Where does it even? Yeah, it goes into the also here sections node of bits of like hey t2 things. Okay, so that's all we want. Let's generate that. We could just write out the text for that, but actually, so int is yeah, that is because int is 32. That's we will see how precisely we will do that. Okay, whatever. It into a new microphone. Last time I watched your very poor quality noise. I don't think I ever had poor quality. Maybe initially I run this without a compressor. Actually, this has with my lavalier microphone. I would say for years I had good quality. Just with this allows me to move a little bit freer without ripping the microphone cable. Sounds like you want. Write a compile and IDY, waste time on language, open source. What do you mean IL? That would be appreciated by way more. What precisely? I mean, compiler and language. So the thing is, I want something safer than C and less cursed than Rust. Like there is not a language that I 100%ly like. GCC emits every operation for every. Yeah, but like why does it? Like I don't quite. Internally we would also, but like I just don't see those. I mean, probably internal function, prologue, epilogue generation and things, but yeah. So the release a one-to-one translation is extremely useful for debugging. Like you want compiler one time on a language. So the thing is, a compiler is always for some language, right? And C is too. And I'm not writing new C stuff. Like I want a language way better than C and less complex than C++. Basically, I want Lua with like a sane Lua with static typing and stuff, right? And I don't want to implement a Rust compiler or is a compiler, right? Comment there was largest impact on optimization is inlines. Yeah, probably. And stuff like this inlines vectorization. Cause they do SSA optimization easier, but there are lots of optimization processes. Figure out what to run when easy. Now you want background noises. They are gone now. Rauschen, yes, noise. Okay, maybe the love mic had more noise. I don't know. Also, I run compressor, noise remover, things. So, using Git. You should start to. What have you ever contributed to open source and stuff? Gradle solved JVM's problems and it solved Gradle JVM's. Guess you're right on that one, but I guess. Oh, okay, let's get more stuff done. So what we need to do for that is the types. So we need, so where is it? So parse function. So we need the arguments here. So what we need is for each scope, we need to track the arguments, we need to track the types, we need to track local and global vars and so on, and build some static assignment form, right? So basically function arguments here. So now comes all the actual hard work. Where do we start with what? Basically, where did I put my abstract syntax tree? So basically here statement sequence. We only have here return, right? Return var So we have here assignment, compares some things. This is what some abstract syntax tree look like. This is what we need to build next. Like basically function, storing like each of those things. Even in Lua, you can like, implementation language doesn't matter. Like if we would do that in C, we would need to have custom structs with arrays and stuff, right? We will just throw this in untyped Lua tables. Didn't realize here. Yeah, I'm only saying, but that was my point. Also, like maybe if I run it with, probably initially I run it with nothing, right? But again, so if you're still discussing that, my argument would be that it is extremely silly that the compiler generates that much internally, and like for, I mean, sure, unoptimized for debugging the compiler, but yeah, it's really not. It's also funny how the compiler, so actually it saves it, right? Like internally, so it internally, probably because maybe GCC stores everything in memory. And okay, probably it does it because it reserves these 32 bytes. That's actually for our integer. And then it stores here that it even restores. Okay, it stores a frame pointer. Wait, 32. Why does it store a frame pointer? Why it has 016 20 4 SSD is, why does it do it like that though? Wait, okay, that is at immediate. It's crazy, a lot of stuff. Sign extend. That is simply okay. You need libraries, package manager, ESP, and all the tooling. I mean, to be fair, you don't need an LSP. Also, like we need some core library. You're talking of why I do this? Once actually simplified all good. I never run O0. I mean, I run it without arguments, right? Without arguments, default O0. That's what it did. I'm only saying it's somewhat crazy that internally it does it like a first step even. We will see how precisely we will map that. So of course we need libraries, but my point is also like most of the libraries totally suck anyway. So basically, I want a great reset with. It's like most libraries are C anyway, so we urgently want to get rid of C, right? Like, package. You need like, so also like you don't need package managers, right? Like you as also like don't tell people who want to do amazing things of not to do it, right? Like if you tell Linus Torvalds like, hey, why do you start a OS? We have Windows 3.1 and we have some Unix, right? So also like to get started with C and stuff, you don't need libraries, right? I mean, C has some standard library, sure, some standard library. We need some core library and some, right? All the other stuff is optional coming later. And to this day, I didn't use an LSP because okay, so usually there are patterns of ASM for each op in SSA. That's why it looks so noisy. If you write simple stupid shit, it will be the same. Not necessarily. I would hope to. We will see how maybe we map everything to registers. Maybe it be like so. Maybe a more modern way would be to assume we have infinite registers. And like 4 billion or whatnot, nearly infinite, and keep like and optimize and stuff on registers and only spill to memory what doesn't. Like, of course, usually most things don't fit in registers, but like only spill, like allocate stack space only for stuff to be loaded and spilled in. But we will see. I'd like to get rid of C as well, but you can't even load No, I need to scroll. It scrolled away. I was like, if we chat the whole day, I get nothing done. Can't even load a graphic driver without linking. You can. Actually, Zig by default generates libc-less code, right? Like, so you can do everything without C, just most people don't. Actually, Zig is, basically Zig is exposing a bug in our T2 package manager because currently the Zig installer basically write file because we track libc files. So at least some form of canonical is nice. I mean, my language will probably not have some canonical package management system. I hate this. Like, maybe we have some, maybe we do this truly cloud. Like, also like C doesn't have this, right? Like, basically F code tables. I hate this modern package cloud central orchestrated stuff. Maybe we will define some spec file that you can put on your web server, your Git repository, and like, instead of one, I hate this centralized cargo things. Like, if you desperately, like, basically just have code and build it, like you did in the C days, I'm old fashioned in that. And sure, we could have some spec file, but I will not run a central report. Hey, first we need to get a language running. I'm only saying, people always overthink this stuff. Like, no, like, I just want a good language for me or us. I mean, I have seen so many horrible abominations of Git or CMake to do package management. It wasn't even funny. I mean, cargo was also not funny, right? People usually mess language semantics, core libraries, the same as clinical. If you want to be productive, you would not stream. Okay, fair enough. But I also want to, basically, if I write a language from scratch in a year, I earn no money. And at least if we live stream it, I also want to build an audience. Say that to your colleagues. Pretty sure I'm using Zig. What do you say? At least the file doesn't. glibc can't be loaded. Say that to. Which one? Zig? The default target. I mean, our T2 Zig. I even googled this. The default targets, they have like Zig and Zig libc and stuff. Or maybe we should just change the default target to, yeah. Because like currently, if we Zig build and install, T2 doesn't track the files, so it's not using it's using its own static build binaries or whatnot for its own installation purposes. Let's see what Zig does. Load from Git repo with a spec file. Sounds good to me. Sounds good to me. I don't like this micro dependency. I was like, this is micro dependency. Hell is the worst. Language package management have created some bad incentives for devs such as micro devs. They become popular, but it's, yeah, okay. So good. Let's get some more stuff done. So basically, how should our stuff work? Like, it would help if we would have some graphical application, but maybe another day. Let's for now just get the most minimal stuff jitted. So if we, okay, to generate this, how do we want to tackle that? Do we want to throw that through the assembler? So assembling stuff is super easy. Famous last word, super easy. I've done that. So generating by machine code is simply looking up this, or simply, relatively simply looking up the instruction in some tables of numbers of ZZ and code Z. It's always just, it's extremely straightforward, and that's the most interesting thing here. Basically just typing all the stuff. Like, it's just like the RISU type, having some table of instructions and then mapping load, store, and stuff to that. As an initial test, we could actually spit out this text and then gradually one by one. Thanks here for the first time chatting. Languages could easily implement useful most of the stuff that will fit your program better. Spend the first 30 minutes talking about the language. And the fact is, when developing a compiled language, you have to talk about compilers and use package maintainer, very well known compiler problems. Probably missed something. No, he spent 30, but you could In fact, I think it's good language. Okay, I want better language. Talk about almost exclusive. It's not compiler. So my compiler, I'm not saying my compiler will have improvements, but so I talk about compiler because language needs the main thing is a compiler. So naturally, I mainly talk about the compiler. I never said my compiler will be improved. I only say it will be more minimal and simple. And I always said we target 90% performance, hopefully in the best case. We will see in the case of vectorization. I never said we will generate better code. I always said I hope I generate 80 to 90%. Maybe in the end, the programs run at a similar speed of using more sane call library functions for string and stuff and arrays and so on. I never said I will create the world's fastest compiler. Maybe we create the world's smallest compiler, but although probably not. Like TCC was a like tiny code generator, was the world's smallest compiler, but most readable. So the question is, how do we want to store that? We need some kind of abstract syntax tree. So normally, how you would normally implement this, you would have some C structures like in GCC or Clang. You would now have some custom data type of struct, AST node stuff, or whatever they call that. So the way you need to build your language is that this is highly generic and systematically, so that you can optimize that you can track used vars and stuff and generate the code. The way this works here is then that you parse some code block or function into this abstract syntax tree form, and then of course run optimizations eventually. But even without optimization, you just generate you generate code from that from the beginning with all trees to the end, right? So to start that, let's do some more work. So parsing here, so that is currently all extremely simple, like really store and pass the arguments. What should we do first? Like maybe we first, like if we, basically what we should do is implement everything while we encounter it. I would say that is a good strategy. Let's so first tokenize the stuff, parse the functions, like match, like what's the function, what is other stuff. This is here just for error handling. Expect here that. I already prepared you some expect things. Expect basically it means nothing, just to by the way, do I have what did I do with if with body? Actually body I do. Okay, that is not yet. Yeah, that's not yet nested body. So that's not bug free yet. That's just the most minimal. Let's do one pass of token parsing this stuff. So for everything, for every code construct, we would now need, like, so this is the most simple thing, right? Like it becomes like for this thing, it is extremely simple. It's a function, that's the arguments, that is one return thing, that is one addition. It becomes immediately more complex if you define more things, right? If you define more vars, right? So the next thing would be A equals implementing assignments, A plus B. Maybe we actually should do that already. And then the next thing is parsing compound statements here, or C plus whatnot, right? So that would be the next thing. And actually, this will actually be optional, to be fair. So this is all the next things. Like it's basically each time one step of parsing and generating more complex things. Should we? So even for this simple example, we need quite some infrastructure. How should I leave it? Okay, it also doesn't really matter the most where we. Okay, let's leave it how we had it. Or let's maybe to incentivize here to implement some more stuff. Let's do it like this. Like just so we have a statement. Actually, we could to have to parse all this stuff. Like maybe add here some optional stuff just to parse it. Maybe. Okay, let's make our lives a little bit simpler. So that's the stuff, right? These are the tokens. Now let's parse it. Function. We need two arguments. Sounds like you're going to risk. Going to have risk support, which you mean risk CPUs? Yeah, so my pet hobbit goal is also like I also want this. So not only I need a replacement, like basically Lua developed in a way I don't like, and we could use it in our company. And also I hate that compiler people drop stuff, right? So for the future I would theoretically also want to support DEC Alpha Ateneo, and because even DEC Alpha was deleted in LLVM, and even Motor 68K is only halfway, like a little bit support. Like basically it's also like securing the vintage and retro future of having actually a maintainable, super tiny maintainable compiler thing. Okay, arguments. So what we need, we basically need some kind of data structures for our program. So here's the arguments. Where do I pass fn? Like, so we have here, I have here the return type. So T type return. Here's a name. This is currently Pullman Sings. This of course will vastly change then in the future. This is just debugging. So here are, where do we have things? So here are the arguments. So basically, what we need is some type of parse argument. So currently I just throw them away. If you remove, replace int with var and derive with type and remove return keyword instead. I hate this implicit return. Like I hate this with Rust. Like basically you're proposing some things which I really, really hate with Rust. Last value in each possible flow parse of a function. If you remove this, replace this, what do you say? Last style you'd have f hash syntax. You would have f hash syntax ml. Okay, let's look that up. So I only looked this up because to learn something, and for his live streaming experience. I do have syntax examples. Wait, somehow this looks vastly. Wait, what? This looks vastly different. So here's a touch Rust f hash and elixir. F is OCaml plus plus. Nah. You say also you set LM as language, right? This looks somewhat. Nah. Why did you say that? Oops, send out. Okay, we can close that. Can we have like I just want to see what you're throwing at me. Just hear some string number of times. Just some hello world example. What? Why is this so? Wait, this looks absolutely horrible. is that really the lang? Yeah, that is all I hate from, like, what? Why do I do my own language? Because I'm not liking what I see. Okay. Let's create some data structures. If you have implicit return, just go full functional language style and remove return alt. So the problem with that is, I find it hard. It makes code. It makes reading code more difficult and error prone. The only thing I considered that, and maybe we will implement something lightweight. The only here for that, like if but so the problem is readability, right? Like how do you instantly see that this returns like either this, like I find it stupid. Like I like Rust safety, but like how is this, like in my opinion, so this means like this here, like this would return either A plus B or A minus B. Like I find the readability absolutely horrible. The only thing, welcome everyone new here. This is a huge brainstorming stuff. I hope our stuff would gradually get more efficient. Like today is basically summary session of like everything I language brainstormed the last month. I like implicit returns Erlang because you define functions using pattern matching and things of, I like explicit statements more. Yeah, me too. Like there is so much stuff stupid in Rust that's like, no, I don't want to use it. Like I don't like the syntax. I don't like these things. The only thing I'm not the most happy with this question mark operator here. Like the only thing, if we would for assignments, like the only thing explicit return things, would make this here, like if then we wouldn't, if we do like maybe we like maybe because then this would work. If else so as our language should be about simplicity and readability and stuff, right? And if we make the, and so I only, and this is not like what AD I only go for, I only let you influence me this brainstorming because we are still in the early process of what do we really want. And so if we would make this implicit return stuff work, this would work. And maybe a way to go, like, so the next thing, like, remember earlier, like 1 hour and 40 minutes ago, I said, I'm not yet 100% sure about this here. But maybe, if we would make this optional, like in C, although where to, like, so the only thing is in C, you would need parentheses here, right? Like, so this would be valid C. I mean, except semicolon, of course. Right, then it would be valid C. And so our language will support semicolons where necessary to, like in Lua, like usually you don't need semicolon. Because if we say like this code scope things here are optional, then because in like until today I was like, nah, maybe we make them necessary and then we avoid all this problem altogether. But like if they are explicitly needed here, if they are required, then this would look like this. And if we would make them optional, this would work. Which is all right. So Lua would have then here, like Lua would be if that then. Only readability noise. I mean, the only thing is I get why parsing this would be a little bit so that's of course like if you spend a year with your inmates to language design that, hey, thanks for the subscription, highly appreciate this. Of course, it helps to define some proper grammar, like theoretically grammar for like to like with formally verified grammar stuff, like you would know where there are ambiguities and stuff. The question, like of course, it would be too theoretical here. Like I'm not even like I'm 15 years out of theoretically, like 50 years in practical and computer science. I forgot most of the stuff, to be fair. We need to see what we can support. Actually, here's what requires the ability to return, continue, and break for normalizing loops and conditionals. I'm not sure if everything is in language, but macros regularly to have clear. So must this be which one? Which system most good devs will do either A or make a new one there. Some var now and something then. New line where. So I'm only brainstorming, like basic, but brainstorming is also important. Like first we need to understand what do we really want. What so I want to type as least like if it's not strictly necessary, like why type it, right? So we are really close to Lua. Like for our compiler, I don't see a reason why we should enforce parentheses here, right? This is why like it's closer to Lua, right? Python, I don't know. Here's this blocks. I mean, this is why initially I thought like we explicitly need blocks here, scopes or whatever. We will see how we will later call that. It makes many people enforce it anyway and stuff. So the only thing is like some assignment thing. I mean, this would even be some Boolean, right? Like a less than b, so that would be a Boolean type, right? So that would basically assign. So then if you had some question mark operator here, then I mean, so I'm not yet sure if I should support that. Like if we have, so Lua doesn't have that. In Lua you can do this with if, then a. Actually, wait a second. Wait. Actually, in Lua you can do a short form, but that is a little bit tricky. Like if the and a or b. Actually, in Lua you can often do that though, which probably only works because that returns a value and that's not nil. I'm not even sure if that is anyway, it's not the most important. Initially, we wanted to yeah, the question is where new line else or yeah, okay, so it's not the most important thing. I'm only saying we should rather implement less than more, and so that are this kind of design things. I only got here again because people said implicit return stuff. I would, however, argue that I would hate that my language supports this and this, like, nah. What did I even delete here? I probably had here something or whatever I had here. I had here return. I really would hurt. I really would hate if my language would support that. So, if I had a choice between no parents and false parents, the latter I really don't like having to remember. Yeah, also operator precedence will be greatly simplified in my language. I hate that C has 13 or whatnot levels of operator. Like each time the problem with the C13 levels of operator precedence, each time you type something, first of all, the compiler will shout at you, like, put parent there because like operator precedence, like, no, this is how I want it. Shut up, compiler. And the other thing is, I need, like, if I write something sophisticated, like non-trivial, I need to go to some C language manual. It's like, what is even so? Yeah. So operator precedence at all just don't have so I mean there will be some operator, like if you operator so there will be like math stuff of like there will be like similar in mathematics, like to be able to write A plus B, A plus C, right? In my opinion, that you want that. And what I did in our Lua fork is that maybe only 2 or 3 levels operator precedence, like basically multiply before additions and basically similar to math. The only thing is like shift and stuff, and XOR, like their stuff gets tricky, right? And that is where I regularly, like, is it even like a shift? I kind of would like, the reason the C operator precedence probably is so convoluted because like in the 70s or whenever they invented C, they probably implemented so that for their PDP-11 or whatnot, when they wrote their low-level code, like to be able to like their style of like accessing memory mapped peripherals and stuff, I'm pretty sure they made it so that that kind of hardware shifting and masking stuff they could write with the least parents possible, is my guess. Makes them cause is that modern devs aren't able to write. Also, like I don't. Yeah, that's the thing. I also don't care about framework. Let's first let's focus on making a good core language, right? Like also like also like our code we write with some least frameworks possible. Like everyone should actually do. Given how often I've seen people confuse order precedence, especially switching languages, just always. Yeah, so I also like often I write like shift, like where do you need operator precedence? You need this with like shift, like shifting stuff, like shifting memory map IO peripheral things on your PDP-11 or RISC machine. And like often I write code. I sometimes I was like, was it the right order? Especially if I did too much Lua and whatnot, and go back to C++ or stuff and like manual. Okay, that's the right order. And then the compiler put parent there because do you not know operator? It's like, hey, I opened the book and looked it up, right? So, and then just to get rid of compiler warnings, although the code works and is correct and stuff, then to just satisfy compiler warnings, you add them back anyway. But I would argue like 3 or so levels of math, like basic math, like of, and then making shift, like, because shift is basically multiply, like make that the same order like multiply. So also like basically make like 2 orders of multiply before additions, and that's it. Like there's basically, again, make it stupid simple, and as you say, like some basic things you need, and everything else put parents, problem solved. Yeah. Okay. So so the reason I even think so much about this is I would want to attract, so the reason to maybe not have parents here, and we will see if that is but basically the thing to make this work here basically is what do we even have here? So maybe we can make this optional. I mean, the crazy thing is, given that our compiler does not really need, like, so the function definition ends here, declaration. I don't see why we need that here. Like, I would argue, if we make it optionally here, like basically for the compiler, that is one code body scope. I would argue then it should be optional for functions, and then that should work in like our test function we are currently wanting to assemble, and then we got sidetracked. Like if we make this optional, it should be optional for functions, for everything where you have some scope. So that should work. And maybe that would be amazing. A plus B, right? Like, because if we make it optional for any other where we have some scope, then that would work in our language. And I mean, do you usually need that? No. But then at least it would be some function thing is either one what basic block thing. What is that basic block? What is it even called? Do we have? I mean, I understand. That is unique, aka void. Totally agree. And if you calling, okay, we had this. So yeah, basically, actually that's called statement, right? Looking up 25 years ago, I read the C language specification. Forgot. Yeah. So basically, one statement or scope thing, whatever maybe we should make this work here. Then it's basically, then that would work. Which the only, so where does that end though? Like C equals. I mean, there are some complications. How does Lure do that? I mean, if we would have explicit semicolons, that wouldn't be a problem. Like basically a semicolon, like every statement semicolon, right? I mean, I'm not that wholly of avoiding semicolons if all the other stuff is amazing. To be probably Rust has mandatory semicolons, right? So optimizing semicolons away is not my, like, the rest of the language needs to be amazing. I was only considering that coming from Lure. That would remove that ambiguity, except actually it wouldn't make this work. If A less than B, yeah, there are still like, but I mean, maybe we come, if we would have like C explicit parentheses here, we wouldn't need that here. Then we would need to have that in parents, and the problem would be solved. So that would be if A, then the problem would also, the only thing here is if like A, so all the actually here's as a forced semicolon would break that. So the thing is, maybe I should. We are writing a new language. We don't have syntax highlighting yet. Statement is just an ignored expression. Yeah, so forced semicolon doesn't solve anything because it wouldn't make this case here work. So if you design a language, you always need to, I mean, sure, formally writing it down in some formal language would help. Yeah, it's not the most important. Let's first gen code. I'm not yet. I would like to support parentless if. It's just like, I mean, there is not an operator, so I mean the compiler, it's like this thing and then here operator, so like statement over. Basically we could have, Lua also has this of like, you can skip semicolons where it's clear or stuff. So basically so you need to think of the way of the compiler gets this in tokens. So basically it gets B and then it gets A. So basically that probably should be possible to support, I would say. Because if we would make something like that work, then we could potentially not need a question mark operator thing. I would hate to support, I would still argue function, like even if we make statements implicitly return their last value, is a well computed value thing, to make this here work. I would still argue function returns should be explicit, because I would really hate to support this here and this accidentally works. I find this is, although this is valid Rust code, I hate it. I find it really hard to read. In general, I find Rust code hard to read. We are using a manually written, like we do everything from scratch. You can, yeah, Lua also has optional semicolon. I didn't quite remember Swift had that, but thank you for the, as long as it's immutable, it would keep an eye on it. The rest is less important. As long as it's immutable, I would, which rest of immutable? Everything is an expression, but return must be, yeah, something. I mean, something of that I could agree with. I just hate, like functions returning random things. It's like, pfft. I mean, so one thing we have not yet discussed is memory safety. We will first, I want to get some basics working. I'm aware that's not the super most amazing. Like if we would be at the university, we would have 4 years brainstorm formal verified theoretical language definition things. But we're not at the university and we want to get shit done fast. And so we did not talk memory safety. I've not even thought the most about memory safety, because it's difficult anyway. And I rather would want to get some hello world example here of like, get some minimal stuff working fast. Can you please look at ATS language before we decide? Okay, ATS lang. How many language should I? Which one would that be? That one? Applied type system, multi-paradigm of first appeared in 2006 things. If what? Oh my god. Is that like why? That looks absolutely, is that the freaking language? Fun? I was like, fun, a no-go. Like, nah, readable. Like, are you freaking, like, why do you prove like absolutely horrible? Like, do you want to destroy my brain? I don't like. Good ideas. Oh my god, this is shitty to read. Sure, I don't know the language. I took a first look, but I really don't like what I see, you all. If on a first glance, a language, yeah. We also did not yet talk about include module things. That will be for another day. Let's, not the syntax, yeah, obviously not the syntax. Yeah, as a, like, if what has, some language has go fun, like fun not acceptable, we're not here for the fun, or it's like if with two ifs, like with two f, like what? Fixing of whatever if does, like, nah, I'm not. Anyway, pattern matching, yeah, okay, fine, whatever. Okay, let's pass some more things. Where we? Let's maybe save that. This random stuff. Not sure. Probably plus minus, give or take some things. Cheers. It has a novel approach to verification where you pass proofs in the type system. Never make fun. Yeah, me neither. Yeah, as much fun as I like to have fun with my machines and stuff, but yeah, anyway, I would never use a language professionally that has a fun keyword. So functions, we need to parse type, so we basically need to that here. So yeah, to do true Codegen, we need actually quite some days of work to properly pass it to an abstract syntax tree, to and so on. Let's get started with types. Where would be which so where do we really start here? Really parse and store arguments. Let's maybe if we initially start here with if we basically decided that maybe it is a good idea to make functions. Okay, let's initially support this here, just because then we can implement any code block statement thing and makes us even more minimal. And that's all what my mission here is about. My next mission here, now that we have an amazing Linux distribution, is make programming and language compile implementation great again. Friend, that's true, but friends much better than fun. But yeah, but hey, friends is much more serious. And okay, so like friends much more important than fun. So basically that we need to change our parser to expect like basically function. I had here expect that here basically not expect that here anymore to make that work. And basically maybe parse statement. Maybe we call this parse statement. And so then we are function, we are done. Okay, function probably really needs parents, so expect those, error out if it doesn't have that. So that is poor man's quick, like let's quick and dirty write some stuff, right? Okay, stop irritating me with your features. Then parse body. So maybe later we will see in which way or shape or form we will group those. Also, I think I need some handkerchief for my nose. Statement. Basically let that here next token, and if basically where would our write statement? So you don't have unexpectedly nothing returned. What precisely? So it's unfortunately we probably need some context of a parser thing here for where to end. Actually, you know what? To make our life maybe a little bit easier, would it help? Would it help to initially have explicit semicolons? Would that in any way, shape, or form help to? Maybe does it help? Just to know where, because otherwise we wouldn't really know where to stop, right? I mean, we could, so what kind of things would we? Basically, how much, so if we would have if here, if a, what did our, actually writing this stuff from scratch, not the easiest. Whatever makes it simpler to parse it first, put it in there for now. Yeah, exactly. Okay, let's make it simple for now. Let's so return that. Maybe we put that into some array for now, each statement, and see how far we got there. Of course, so there are different parsers, right? Like top down, bottom up, recurse, decent, parser, decent parser thing is different. Kind of top-down parser built from a set of mutually recursive procedures. Does not require backtracking. Predictive parsing is possibly only for the class of LLKM grammars. Dear. Things. So that is bare. Yeah. So obviously, even in GCC you have, or Lua, you have like if this then that and stuff. Like basically, let's see how far. Let's. The thing is that currently, basically, we would need some context of, are we in some if, are we in some whatnot thing, right? I mean, with our hated, I mean, it's crazy that if we make implicit return stuff like this would be valid. Which might not be the worst thing in the world, but which one? So something like bash, ASIC exiting a path filler, something. What? Prod parser really simple and convenient. Prod? Never heard of a prod? Prod parser. Simple, but prod parsing. Operator precedence. Another procedure parsing was described in 1973 paper top down. That's what we operational procedures by simple shift reduce the couple of parsing a subset of LR grammars. More precisely, the operator presence parser can parse all LR1 grammars where two non-terminals and epsilons never appear in the right-hand side of any rule. Yeah, so that is how you should write a parser. Of course, it's not how modern people should be ChatGPT that. So let's first pass stuff in for each statement and like let's make some stuff work. So let statement be some array. I guess this is because this is some Lua mode. That's not Lua. Output function input another make no. So so statement actually okay, doesn't also the order doesn't matter. This is our globals for now. Basically get a token, and if that is token is, so I got to use I got used to use underscore for temporary things I just work on. So then if that is, then, and so I write this in Lua because this is reasonable close of what we're targeting, right? So with the goal is when we got some initial stuff working in some months, we can convert eventually, like in a year, from this Lua fork to our own relatively easy famous last words, right? So then basically the whole statement, or like do we save this already? Let next token. Okay, statement equals parse to body. So we don't need to print everything here actually. So until, okay, here we need a semicolon theoretically. So either, so okay, basically we need to parse it first. You would bootstrap it, right? So you would bootstrap it, right? It sounds like good, cool idea. So this one. So you mean, so I lose Lure because that is in my probably 10x more efficient than dealing with segmentation for like basically a probably hopefully uncrushable language to work off, right? I just realized we only need this once. So basically here let that be the next token. So statement is like let's just store those tokens there. Came here, watch your stream, which burned your eyes, which do you want another color theme? What burned your eyes? I just you're criticizing my nice color. Also like, okay, let's not waste our time. You're the first to. How do you burn your eyes? Oh, well, what's the problem? Okay, so if that's a start of some block scope, then let if that then parse body. If so, let's that statement equals that, then probably okay, statement equals that. We will see how we later need that. So either parses as a whole body or otherwise parse else, if then else, until else. Statement. The first statement is that's already some token, and then repeat so this needs more error checking, like we want to get somewhere, right? Like it's later needs some, we need to add some file name and line number accounting and stuff, right? To next token for better error diagnostics, but that is for another day. So then store all other. So we would need to check for semicolon, but I generally hate to check for stuff repeatedly. We could make this actually until it could also be nothing, right? Like basically everything should be if not that or that. Actually, okay, let's until not a token. what end? At the end, return all the statements. That is Lua garbage collected stuff, right? So we can just pass stuff around. And yeah, I mean, I could change my Emacs pack. I don't really feel like messing with my bloody 20-year-old Emacs theme right now. I mean, yeah, I agree. Like usually my streams are black, like usually VI and stuff, like usually raw terminal. So that's what you get. Like let's save that of not to lose our precious new code. The thing is, I shouldn't, but I understand most people don't like it. That is just where was bloody edit? I've not done that in 15 years. Where was options phase? That was right. Customize things of just blue sample. Where was even bloody this was somehow sorted alphabetically or stuff. Text cursor, where is bloody default? Where is bloody background? Pointer, text cursor. Yeah, usually I don't dot file, which is also why, but I understand like if we go forward, we probably should make this a little bit mode line. Where is even yeah, I guess YOLO. I do this later, otherwise stream time wasted for color nonsense. Usually I don't waste time with color nonsense. But I will fix this tonight or so. One and for all. So we should write our editor next, right? Like once our language is bootstrapped, we should write an amazing editor and OS microkernel, right? Repeat stuff. So basically, so until not, like basically protect against no further token. Also error handling, YOLO and stuff. But basically, what do we have? Did Lua break? Right, break continued. I think that had break, right? Break. Do we have then break? Yeah, okay. So many languages, I start to forget details. You all. If because then we only need to check this once. I like this invariance. If that is semicolon then break. So in our future language it would look slightly different, but so if we are still here, then we have a token and then we statement. Actually we could make this more symmetrical, also slightly worse performance, but more symmetrical for statement +1. Oops, +1. Maybe you can write this with even less invariance, but so at that, like if we have a token, then at that, of course later we need a pool tree. We will need to do, could be a graph with entry point. What you're saying? Do not forget the UI framework. And hey, I have a UI framework already. You know what? Once our language is bootstrapped in some months, good news. I have a. Do you not know? I have a UI framework. I only need to port it from Lua 5.1 to like, look at this precious 10,000 lines of Lua code. It's amazing. But we need a graphic subsystem and stuff. The thing is also language first, because like the more code I basically I don't want to have you seen what clusterfuck what there spreads the UI. Like the master plan is to write a microkernel. Like basically the master plan is to rewrite everything, but we need to start somewhere. Basically we need language first because it's fun, and we need the language to rewrite everything anyway. And the longer we delay our language, the more code we need to write in lightweight C++ or stuff. And yeah. And basically Lua 5.1 unmaintained. Basically, yeah, I need some minimal language to going forward. So oops, let's try to parse it. Actually okay, let's okay, so does that still, what do we have here? We have So tokenize fn, that's a function, that's our, we also need some better debug printout, but YOLO. Okay, we have some, okay, statement, some typo there, SMT, I meant statement. Maybe we do two functions, statement to test parsing function, so statement there. We probably need some debug thing of print, I hope, was it table unpack? Oh man, it's been some days since I did Lua, didn't write the most Lua codes last year. Some years ago I was more fluent in that. Call field unpack, maybe it's a global then. Like Lua API, Lua framework's also not amazing. Oh, that is better. Okay, so you see how amazing that is. Why I want a language like Lua just better and stuff, right? Checklist. So yeah, language, kernel. So we will work on kernel and graphics subsystem. I said before, right? If we only do language for a year, it would be boring. So some days language, some days microkernel. Like, hey, have you seen T2 Linux? I can even live stream from it. So Primogen would be proud. In random order of whatever we feel like that week or we need eventually. So so that's what we pass. So that's our statement here. Our statement is return A plus B. Of course, next we need to like step by step, right? How to tackle complex problems. One simple thing. Of course, that's not the final code. That's the most minimal. This will have limitations, but let's move on. Let's add this example. Let's do two functions because one function would be too simple. Let's parse here at least one with you did so much. God, copy. It's what you get working in what you get from working in Emacs. If you work with everything, you even my brain stopped to forget stuff. Let's make that here two statements. So just let's make here int c equals a plus b. So like just the same thing, just slightly different. So that would be the first statement, and then return c. That would be two statements. And so let's see what that currently doesn't pass, right? Unpack things of statements, things of yeah. What to get here? So we pass the first one. We probably okay. Then we pass the second function. That doesn't work yet because next we need to implement this body thing here more complete. This was a poor man's implementation of garbage, of course. So let's change that to really parse and store. Like really parse that. Let body equals also the table for now. Emacs just does not yet know about our Lua fork. Can tick editor. Now you can notepad noted notepad like yeah. I mean, to be fair, I have a simple editor. Like I'm not sure if it currently works. Let's see. Did I build that here? All right, I didn't. Okay, it doesn't. I can't showcase this because I installed that. It will not build. I have with my, of course, with my UI subsystem, I have a test like a poor man's notepad editor. I have already like 100 lines of text editor using my superior Lua based UI thing. What do you mean with backslash? I don't know what, but I want my backslash in. You mean without carriage return? Anyway, so body. So basically our poor man's first try of a body is like, of course we need a tree, right? Like currently we only have an array. We fix that soon. Basically that is similar to a statement, just like basically for any body read statement by statement, basically. So this is not feature complete. Like this will not even parse tree-like structures, like if just like step by step, right? So let that be parse to statement from our stream. That should be something. So actually, where do we actually we need to detect Okay, that's already starting to get tricky. So we will get our statements. The problem is, so we will get this table for the statement. We will get a table, then we get that, and then we get an empty table. Okay, for now on, we could, as an initial proof of concept, we could, if empty table, then it was an empty statement. Where was my, here's the body. So if until not, can that be not? So next we need error handling also. Currently this will just randomly throw some random runtime errors if stuff doesn't fit. Statement, so parse body. So function is basically, what do we do here? We simply function, what did I have here? Statement. So parse statement might be some, yeah, we need to define some proper terminology. And thanks for the subscription. The language will be the next C, I guarantee it. I hope so. We also need a proper name. I've not yet even a good name for the language. We could play on Lua and like use some, hey, like Pluto or stuff. The only problem with languages like Pluto and stuff is like good luck googling Pluto, like Rust++. Yeah, more like Rust minus. You this will be orders of magnitudes less complex than Rust, and I've not yet even thought about memory safety. Memory safety last. How to make a garbage language by putting modern memory safety. But hey, this language will not be that as unsafe as C. Like maybe we make this like some memory, like if you use unsafe low level things, then like you're on your own. Like maybe we make it, if you use like auto standard container things, then it's safe, and if you use low level types, and I've not yet thought about this, to be fair. But I understand that other people's priorities is memory safety. My priority would already let's make minimally workable stuff, right, and care about memory safety second. So so we only do statement here because statement is basically, looks like maybe we make this block or whatnot. Nah. Maybe we call this block or whatnot. Body is a little bit now code block or whatever we want to call that. Parses block. So this will recursively parse blocks, right? Like because that's statement. So if that is a new block, that probably should already work. Here's our block. Let's store that then. Like basically, if that is what do we return if that is just an empty state? So I mean, currently okay with semi. Okay, yeah, this needs more, like actually this needs actually explicit. Do we have this? Basically what we need to detect is, I mean, if what we could do, like if the statement, like maybe put it back. Do we have, we could add a put back thing to, like basically parse. Or we do actually, so usually in some parser you could, like what you often do parsing things like parse something, it's not what I need, or it's the end, and or whatever, right? Put, like there's even with C++ streams probably put back or whatnot, right? Or like read the character and that's the end and put it back for the next consumer, right? That is a common common pattern. common code pattern. We could do so what we need to know is, so it could be an empty block, right? All we need is eventually this parent, and basically what we could do is we could pre-path that, like, and because we don't have some put back things, we could add here some statements that we pass in, like some object or other, and like basically if we get some table, because it's statement, right? Like basically we could pre-pass like the first thing if like the like the table we get in here is an object thing, object or a new one, and because then we could because we need multiple blocks, right? Like, so basically we might at any time we need to parse statements until we have the closing parent. So let equal next token. Is it next token? Next. Yes, later object and stuff, right? Like it's another day. Like first let's Codegen 2.5 hours later. But yes, of course it's some talking entertainment. No, I want, what are you talking about? Like I would want, like I don't want to learn every reassembler. Just like some nice moves and anti-power checking. But it's fearless. Good naming is the hardest part, exactly. I don't start here with naming, like it's just next lang, like just lang legit thing here. Okay, so to simplify our parsing, so basically next token, if that token is end, then if that is equal closing parent, if I would learn to type, if that then break, if not, then let that like pass in, that's the first statement, so pass it in as a new object here as that was the first statement, then the statement thing will fill further things until the semicolon. For now, so what can that return? Until nothing or stuff, so it should return always something, right? Like, is there, okay, we can leave the safeguard here until, not sure if it currently can happen, but let's see, does that work? No. Bad on table got null for 227. 227. Where are we? Statement, unpick, statement, or actually we could shadow that. I think that should work. We could basically first statement. Actually, we could even further simplify that. We could even, if that is usually actually this is even simpler. Look how amazing it is to write in dynamically typed Lua. We could basically the first statement here, like basically that. Basically your first statement, and if that is null, then it's nothing. As our and then we don't need to table, and we basically put in here the first string statement we read. Otherwise it's nil. Look at that. Dynamic duck type. Writing a compiler from scratch, dynamically duck typed. That is the kind of stuff I like, basically. Yes, it might be a little bit. Yes, we're getting in confuscated C compiler, C territory, but nah. Somehow So what did we get here? The first function parses, that parses as a return table here, return stuff. Then function stuff, return statement in C equals statement return C 227. Let's see, seems reasonable, stable. Mallinks are more of a concern. Yeah, so the thing is C++ became way too complex for me, right? Like C++ was never a great, and the modern I was a C++ 1998 fan, like, but C++ 26, it's like, I'm talking about 40 megabyte compiler, not 400 megabyte compiler, right? Let's make a better lure. Statement return C. What precisely? 2v227, right? 227. 227. Statement. Why does it not work? No, a debugger would be helpful. Let's maybe print every next token. Print token here. Ah, we are here. That makes some sense. So int C. Ah, okay, we did that. Token return. Wait, token return statement. C token return C that. Okay, return. Ah, actually that makes sense. Look at that. Unpack table expected. Okay, so we parse that. We just need to log this stuff also better, obviously. But all we want is Codegen first. So we are in the case where we... Ah, this is probably, was it 227, right? 227. Does it make some more sense? We are here in statement, we had the function body. And where do we get if we add to the statements? It's probably the return of the last one, right? Like we log. Where do we token? We could write performance input and see like what many features are way too many features. Yeah, the C++ way too many features. Let's log that better. We need some common sense of basically maybe unpack that stuff here with some. What else? We have statement, we have block. Here also, because the block thing didn't return, our block thing doesn't return the block thing yet. Return block. That's probably the bug. Look at that. Let's add here some global let debug, let trace tokens. If trace tokens, then and trace token, and print stuff. Yeah. Okay, so we got that here in that function, return a plus b. So we parse some stuff. It's, of course, later we need tree structure and stuff, right? So here we get block statement of int cz. So that's block later. Yes. So later we need to read a tree, and then we need to Let's probably not further improve that for now. We just wanted to see if we can parse some stuff, and we can. Let's next Codegen for the super travel stuff, just to get here some things started. And or Python if you like it more. I don't like Python. F#, I don't like F#. The problems, so of course I can use some languages, right? I use shell script A each day, I C, C++, Lua, not even the direction of Lua development. Have I said dual number? Basically I want to nothing less than the great reset revolution of making stuff super simple and amazing again. Good, Codegen. So of course later we will need much more type maintenance and so on, right? And function maintenance, like types and function and all the objects, and maybe we simply treat functions as like some symbol things, like probably everything like function first class values, which is amazing anyway. And then we have one global symbol dictionary things, but that's for another day. Let's just get, oh, by the way, I think I forgot, like let's first, so the CFI stuff I believe we don't need. By the way, where is test, where is even, is that stuff doing that LFE, where is even, I would hope we don't need all of that for. Okay, let's first spit out that stuff, like basically that's all we're after. By the way, I forgot to log out. I wasted here some electrons. That's not ideal. So in a recompiler, we need to build this abstract syntax tree, do some optimizations. Of course, we don't need to do optimizations. Of course, initially we will do not optimizations. Initially, we just generate this stuff directly, load stuff, compute stuff, store stuff, register allocation, or yeah, load, compute, store, like basically virtually unlimited registers, like probably like LVM does. Like I think LVM does virtually unlimited registers, like just everything in registers. Sounds like a pretty reasonable thing. Optimize the stuff, spill the too many registers, like spill the stuff to stack. That would be the plan. So for now, let's spit the stuff directly unoptimized without a proper syntax tree. That is later. So that does not yet have, like, we need trees for like if and stuff, right? But for now, let's directly gen that to see some assembly code. So function, that would be here, parse statements. So that is where we are here. It's basically how to probably call this block, right? It's basically, so it's either one statement or a block. Could call it code or text or yeah. So here we returns a statement. Here returns basically, so either it's one. So the only thing that's of course for symmetry. What do we have for functions? Like basically we know. Oh, here we know. Okay, okay. What do we have here? What do we print out here? These are until not, or let's fix this infinite loop here. The question is, what do we define our basic? Basically, I mean, basically it should be a block, just that there's this, I would say everything should, like, there's It's usually not a one statement thing. So probably the native quantity of code we should make obviously the whole tree. But for now, that means to not, because otherwise we wouldn't need to special case, is that just one statement or a whole block. Let's for now pack this like if we are here, like so statement, I mean the only thing is nested statements. How far do we get? Let's for now. By the way, what did I do with this closing curly braces here? All right, I put that in here. Okay, so if that, all right, I put that into state. Where's the statement? Statement here, I think. Block. Do we call this block? Where did where was it? That must be in here, right? If, let that next token. So, okay, usually we have, so that's a block. So the only, so, yeah, we need proper types in some way, shape or form. But for now, to make our codegen initial poor man's codegen easier, let's surround, let's put that into a table so that it's multiple statements of one that's identical. That is here, either here, parse block, or the only thing. Okay, let's not bother with it. Let's just one statement. I want to move on with the next thing like this. We need a proper syntax tree. It's basically not worth so much time. Did I implement multi-line comments already? Maybe I did actually. Let's just generate code for that and then generate, like, it's pointless to implement stuff that we later need differently. Okay, so the compiler needs to know, like, first of all the vars it needs to look up. So what so of course a real compiler thing, there's a lot of complexity now. Surprise, surprise, there are a lot of details. So we need to keep track of all the symbol names, the global ones, the local ones. So we need some helper functions. Like obviously, some people hate it and stuff. Like object orientation is fine in my opinion. Like basically, we would some object, even in Lua, object-oriented things of lookup symbol, right? And that would take the current local scope, like, and then iterate the other scopes, right? From all the local scopes to global scopes. And yeah, of course, with every step in this machinery, there are multiple ways to implement all the details. Like data structures and all the other stuff. So for now, like, so the compiler even needs to know which argument is where and where does it fit, right? Like there is a lot of complexity next to do, even for our very simple case. So like to map like which name is in which argument and so on. It's actually quite some accounting information now that I think about this. I'm not, so I only meant like for our data structure. So what we next, so for a recompiler next we need data structures and a ton of them. So next we need not only this abstract syntax tree. Again, there are 1,000 ways to implement things. There are infinite ways to implement stuff. We need this abstract syntax tree, but it's one way to implement this. This is how we will probably implement this. We also need what I meant data structures. With object-oriented programming, I meant also even for our compiler. Currently, I have just a loose set of poor man's functions here to parse the first stuff. Later, we would have a class, compiler class with all its data structures, right? That's what I meant. Not like, I was not talking about object-oriented inheritance in language. I was even implementation in our compiler. But hey, even GCC did not use object orientation for forever. Yeah, so totally true. That is why totally fine to prototype your compiler with a set of functions. I'm only saying, like, even for that, of course, object orientation could help with your symbol class and that iterating some tree of local scoping and stuff. So initially we would need to map we would need to map the function arguments, the symbol names, to even register things. So even the next step is quite some, even for this next case, quite some complexity. Let's parse, like let's parse here proper the, okay, let's start to parse the type. So we had a, let's so type, I had already typed def, wait, what do we, okay, type def, I actually, okay, we don't really need that for now. Because we need types. Okay, let's do some poor man type things. Let's just make one type table for now. Later we need more. Here's, okay, it doesn't also, like, the scope doesn't really matter the most here. Next token. Let types be some table. Let's map int. Was it the right syntax? I think so. Let's map that to e32 for now. We don't really need more types. I only wanted to start with this. Like, surely there will be more and whatnot. Just, I mean, I'm kinda tempted, but no, I logged out there. Yeah. I mean, if we, yeah, but we now have int already. For the example, doesn't matter the most. I only wanted to do type lookup, like to complain if the type is not there. So let types equal z. That probably should be not have a typo, right? I would say like this, in some months we could have proper Codegen. And also we should unit tests at unit tests in a month, right? Like basically for each step, like basically then like make changes, make stuff, and like have some examples of most minimal things, and then like make changes to our code structure and like instantly like basically continuous integration unit testing since week sec 2 or so. Only starting to turn into something more reasonable. Keep separate data from I'm happy enough. Polymorphism and are also very common associations. Solid clean room and TDD using every 5 years thing. What precisely do you mean with that? Welcome everyone in chat. Core feature of or is message passing. It's often also about interface things. Good. So internally our my plan for the codegen is that internally the codegen only knows about fixed size integer, not like this byte. We will call not nothing byte and word. These names are somewhat old-fashioned. Doesn't mean that our standard core library might expose byte and word, char is character. Nah. I even hate int and long, like all the C stuff. Even John I totally agree with John Carmack. Integer size, like vars should all have explicit size. Like all this int long, it's complete rubbish. You should, in my opinion, you should only use like, so our language, I had the typed here, like it's this prototype somewhere. The implementation details we will later see. So lang new, probably that one here, right? So all of our stuff, like where it comes from, we will later see. But like, maybe we will do, so internally everything will be maybe internally everything will be even some template thing of like maybe internally it will do something like that stuff internally, and the user will probably usually use I32 and S32 and stuff. And the code gen will only work with explicit types like I32, I64, like stuff. And F16 and 32 and stuff. Maybe some core library will do some type diff to byte and character and int and long for compatibility reasons, but nah. Also, even John Carmack of like implicit randomly sized integer and floating point types, especially integer types, totally bug-riddled random horror show, right? And when will it will overflow at random, right? Implementation defines stuff like it's kind of, so yeah, our language should be minimal and no surprises and no implementation like stuff, right? Like our stuff will be normal integer, 2 complement integer, floating point, IEEE floating point, like, and if your CPU doesn't properly do that, then and not, yeah. Anyway, so maybe should I even map into? I mean, yeah, okay, fine. Like for now, we just need some type, like to look up some type. Yeah, it is what it is. What is even? I mean, long. It's okay. Oh, yeah, okay. I hate char. Okay, let's do here 3. Let's do here 3 types for YOLO reasons. Let's do so integer will be unsigned. Let's char for that just because short. I would say you shouldn't use short to be fair. Is it usually? I mean, it's also like short. It's like I even like the stuff is so like maybe we should not even promote that you all. Oops, what did I even freaking do now? I pasted in this. Oh man, whatever freaking do. Okay, you know what? Let's maybe not even promote char. These types are stupid. Okay, we could do 2 float types. Like maybe stuff like this will be the most minimal thing. Float and double, although even these names are stupid, but we will see what we really expose from that later. It's just like to fill your type table with some random stuff. Later this will be core language stuff, right? It's just like let's prototype here some stuff. So let's parse the type. So we have here type. Okay, did I type dev? What do I have in my example now? Okay, that's what we want to parse. Okay, so no type diff. Okay, so it's int types. Okay, let's let's parse this type. So later, I mean, we need some more type housekeeping, right? Like later we need line numbers for diagnostic and stuff, right? We will probably have some kind of parse look like cursor type of that file name, like for diagnostics. Actually, you know what? Let's do type. Let's do this type dev just to test our type dev. Let's also, like later we will have some size t type. Let's just for the fun of it. Okay, we also like, let's just type dev I16 too short, right? Be type dev. actually lose like so many languages. I already lose overview. Yeah, that's probably okay. It's just so that we have something to parse. Type diff. So then, yeah, it's just so that we can add types already. Type div. Basically, if so, our types. So later more counting information, right? If that exists already, so let's t2, then it's error. Should we error? Do we have here any error? Do I throw? Did I not hit x? What does x? I do error there. Why did I not error? Is that even? I'm currently not throw. That is even correct syntax. Expected things good. Maybe that's wrong. I thought I changed this to throw. If the language has numbers, must be 2 and pitch 2 would impose extreme cost in some systems. Which systems don't to complement can't make this. I think we will not support that, to be honest, you all trap. We don't need to support Cray or whatnot. Like, let's support everything from reasonable 8-bit microcontroller things these days, right? Error type T2, or actually, do I? Okay, let's make this. So let's currently just error out here. Print T1. Okay, let's print it there and types. This should throw. Let's types T1 equals. Yes, later we need more. Wait, 2T2 equals 2. Later we need more. Actually, we need an example of. I mean, we could make it a warning. Okay, let's make it a warning if it differs. Type div. Just so that we have something to test. Attempted to okay, that's what I thought. I used the wrong keyword in the train yesterday. Throw type, so things that's better. Look at that. Type int already defined. Amazing. Good. But however, we could actually make here fn error. Because then we could here already start using actually we could localize this shit next. Print and people like to prep and see, but the hardware landscape was yeah, but it doesn't mean that C should be so implementation defined and these days. Like I find like also I find it hilarious how even new GCC versions randomly, because new standards and whatnot or optimizations break stuff. Like our stuff. Like I rather would forego 1 or 2% of optimizations and make stuff less surprising and undefined behavior. And yeah, C should not have stayed like that for 45 years. Like since year 2000, like C, like yeah, sure there was C99 and stuff like yeah, but okay, let's not discuss all of this stuff all over. So let's make, by the way, do we have some formatting, right? Like expect, what did I have here? Expected T good. That expected, that good, that. Let's improve our life here a little bit. Of constantly typing this concatenation operator thing. We could make this here. That was our warning part typed to check. This is error. Did we wait? Expected that? Okay, we commit our error type T already defined. We need to format that still. So basically, the first thing needs to be a string, and then we can error dash dash format. I think this should work like this in our fork of Lua. Let's see if that. Cannot use outside verbs near. Yeah, we could call it message. Oh wait, I called this S. Message dirk whatnot. Or just S. Beauty. Error int. That ain't amazing yet. Message error message. Type error. Ah, here I have this 2 times now. I had S already. Okay. Nah, I think okay. Let's make stuff readable. Let's make stuff readable again. Type end already defined. Good. All I wanted was a warning. Okay, that still works. 16 short in stuff. I wanted to make this a warning. That is why we implemented this surrounding stuff. Yeah, too much legacy. Basically, I want a great reset legacy free stuff. So that's what I want. If T, then let's basically, we could also make, let's local, like let's make every temp. So people might argue unreadable, but I got used to make temporaries underscore. Then we don't need to look it up twice. So type T if that's equal, then warning. Okay, later we need to keep some cursor state around. 215. Did I call this 1? Error on 1? What? Let. Did I write local? Damn it. Too much Lua, too long. And expected near If then else, of course, and expect. So warning type int already defined. Amazing. That works. Then let's maybe comment out the type dev debugging thing there. Of course, yes, later we need more types. Currently it only has one token type. Let's write package dot what for the right amount of money. Things compiler extension right handling embedded spaces shows the same. All we have performer interface. Yeah, ARM risk like and the RISC-V people copying exactly the same things. Okay, so first warning, yay, type dev. Okay, let's not print that anymore. So then we want to type dev things. Okay, okay, do we want to lock that? Okay, it does not matter. Okay, so next we wanted to synthesize our first assembly stuff here. Oh, Rage was a part of 23, only now realizes. Welcome everyone. Welcome to our channel. How was your stream and what were you up to? Let's give a shout out. Where shout out is due to blah. Why does this not autocomplete? Did you leave? Oh, there. Autocompletes. Yeah, if you're new to our channel, for 25 years I did the Linux distribution, which is amazing, and now that is amazing, I finally have time to fulfill my dream and write a better language, because I'm not satisfied with any of them, and I don't like what I see in Rust and Zigland. It's basically after Linux distribution make. Also, so what I want, like basically next, I probably should wipe code a website for that, and also we need a name. More for human readability, I guess. So for everyone just joined, we want a more minimal and truly readable, like developer first and more minimal code base. Like this will be completely from scratch, not based on LVM, because as much as I appreciate LVM, the massively 100 megabytes base source base not amazing. Also maybe C++ not the most amazing language for that. So we want some micro, like we want our own Codegen. Like this is why we instantly move here to Codegen. Like we have the most, like we started this week after dreaming for that too long. And I want a compiler, like I want LLVM in a reasonably nice language, in like, let's say 40 megabyte also, right? Because currently LVM Clang is hundreds of megabytes, and the whole Rust compiler is 4 freaking gigabyte. And I'm not liking that. And going forward, I basically, for 25 years, I waited for people to write an amazing language, and all we got is Rust and Zig and C++ 26. Okay, Codegen. Function thing here of also like, what else do we need? Okay, we need to parse function, really parse and arg. So let's args be an empty table. And so we write this in a modified version of Lua 5.1 with FN and let and stuff, like basically in the way of where we want that. Just not to make bootstrapping hard, just to daily work on some kind of language that is in the, basically I want, Lua was amazing. I want a statically typed Lua, right, with totally minimal, like also readable Codegen, right? Like I'm a very TCC, yes, basically we want a better TCC tiny stuff with actually, because TCC has a lot of hard coded, like if we just go there, they just hard code magic numbers and other things. Yeah, Lua, I say Lua was amazing because Lua 5.1 was amazing. I made a video previously since Lua 5.2, dual number, other curse stuff, right? Plus, also Lua JIT is amazing. Other people did amazing things. Basically, what I want is I want a Lua JIT in more readable code, and not Lua, but like basically I've like, maybe we should just name it Pluto. I don't know. I just re-summarize this for people who tuned in recently here. Okay, pass the arcs. Like, so currently this is a poor man's, like, quick and dirty, and then like get some stuff working and first code gen working, and like basically the opposite of how universities would do that, like the practical guide to poor man's compiler engineering. So really parse and store arguments. So here's the arguments. So thanks for the subscription. Matic, welcome. Hope you're all doing fine. We finally do language just before microcode. Good. Let. So we have here things that is a repeat thing. So currently we just skip over everything. So that's also parse. Okay, like so parse and store args. Here, actually we maybe group that here. I like to group code. That is the code of return type and name. That's just debugging. We could also later comment that out as soon as some basic stuff works. So that's the return type. Should we call this red type? Return type. Type return. No, it doesn't. Not important. I mean, we could also call it f red and f like function return function name. That's like f args. We will see. Not important. Like later, as soon as we get some more structure, we will rename that to make some sense. Just we first want our first code gen soon. So token, so print. Basically here, what do we? Okay, we have here parse type. Okay, we basically what we want here is actually parse type. Let t be that, and maybe even we could actually have here for name we could have here parse name to start some sanity checking and recycle that here. Basically, all that would do currently is simplify our life. So basically, because we need to some sanity checking. I mean, okay, let's first code gen to do. I mean, yeah, sure. We need error checking all over the place. So to do match regex match load like or non like yeah stuff. What's this work? In test that works. Amazing. So yeah, fast track first. And then what do we have here? We had until not or oh wait, I think we broke that. But it doesn't matter. So we need that, and so basically repeat until not purge type parse. So yeah, this stuff should raise an error, throw an exception. That's to do later. And that's why I basically also in general prefer throwing exceptions. Like basically there is no point of continuing. Like if, I mean, sure, you could always pass more and stuff, but like if the name has already forbidden symbol and stuff, then yeah, right. So each argument needs a name. Actually, wait a second. We need. So actually it might be a function without types actually. Okay, there might not be a type. Okay, I think we want to pass this slightly. For code inside, you need a progressor that can recover from errors. Yes, I know. Like to explain to my later self why I made that decision. Why it's so hacky sometimes. Just not perfect. I'd say 95 of all auto. At this point, auto docs. Just beginner generated fact when anything is what you guys discussing. 90% of all autodocs we've seen are worse than just looking here. Probably. I never really used generated docs. I mean, I can read some ASM code and understand what's happening, but code base was which port, what are you? Docs just I agree that many documentations are like, I mean, sure, but like a lot of documentation spend 50% of the time writing, spelling out the obvious. So actually we need here, like basically we need to check that we get, like we need commas, or like we could have void arguments. So we need basically so what we basically need, okay, so basically this is what I did here was basically a little bit pointless, but we could leave it for now. We need our let we need the next token, and if so either that is a comma or stuff early. So if actually it shouldn't be, so the only termination, okay, so if that is, so yes, I'm aware, so you could generate parser stuff, right? But this language is also often not the most readable, so, and many things are manually written parsers. So yeah. So if I even lure and stuff, right? So if that is, otherwise you spend fighting grammar and stuff like that. I can also handwritten recursive Ds and whatnot. So if that is that, then break. And then we can remove it there, because then it's like not that. And actually I would even like, in general, I like supporting trailing commas also for structs and stuff. So I would just support trailing commas, by the way. No reason to error out of like last comma, right? Like not the biggest thing, but so we have it. So let next token. We need a improved Lua mode for our Emacs. Then break, and so then, I mean, we could already, okay, let's use this underscore. So for each type thing, so basically that should be the type. Let type equals this underscore. Let's save that. Let's continue using the underscore here. So let's next token. And that, I mean, so the only thing here is, So it's basically parsing the optional things, right? Like, so each thing, so either there is an arc or there isn't. So either it's terminated or we continue. Then it must be a type name, right? Like basically, we also need to actually check type here that this is check type T, currently nothing, fn type T. Later checking the type. Because it might be comma or stuff, right? So that it would error out of like expecting types there. Why are we arguing about opinion and shit? Pleasantly surprised modern Java, modern language talks about this. Okay, we are here to write a language. So, in the long term, I would hope that this code, because it's written in Lua, might even be more readable than the C implementation of Lua, but we will see if we can get this more readable. So check type, like currently no operation, currently just need that to do. Let's add here to do. Our language will of course use a common thing. It's just like we need to use this because I probably should patch our Lua for comments actually next. So type check type. So then the next token, that must be a name. The only thing we could support that the name is optional for the case of you remove arcs and want to retain, like basically you don't care about the name, not. But like for now, the problem is we keep parsing random nonsense if you would now, but it's a prototype, right? We will improve this later. That's what happens when you manually write parsers and not generate them. So check type T. Basically check. We couldn't break here because, right? So I hate double checking the clothing parent. We could also let name equal, let's let name we only need that here because the first closing, right? But nah, it is what it is, huh? Okay, let's worry about loop invariance later. Type and name, and we might have so then we need to comma. So again, so we need that because we need the argument order to generate code, right? That's why we are here. That is why we need to properly pass these arguments. So each, like for our compiler, will have the information, the symbol, the object symbol name for this thing. Like it's a function. It has that name. It has that argument. It has that body. The abstract syntax tree body. Later we'll optimize and stuff, inline, all the other good stuff. That's what we are currently doing. So we have the name, we have the type, we need to check the name. So check name here of n. Like it might be comma or stuff, right? Like we might error out for comma and stuff. We will do this soon for, well, we can also call this name symbol, whatever. And so it must have that currently. The only other thing, so it might be comma or stuff, but okay, let's for like optional names are later. Let's make prototype stuff work. So only other thing is a comma. So we are here. We have a name, we have a type, we might have missed, we check that, right? We might have errored out and stuff. If we are here and all the stuff is good, then let's again read the next token. We either have a comma, so like if that is a comma, actually we could even, if we pre-read that, maybe we can get rid of this invariant. Like if we always have, so, because then we could we leave that off? So if, because then we don't need to check for clothing here again, we can just read the next token, huh? Next token, if the next, why does this color so strangely now? Let's hope it's fine. I hope it's misusing Emacs coloring here for our Frankenstein language. That's the syntax highlighting confusing, right? Using the wrong highlighting for the wrong language. Okay, so because then we can fall through here and use this only for like we don't get a token. But then we need to error out anyway. But now, protecting infinite loop. So that should, so if that is a comma, like, so if that is a comma, consume it. And is that not amazing? That is what I mean, like, that's what I'm after. I'm after 10 times higher code density. That's what I meant when I said like programming stuff in Lua, because this is a fork of Lua. Frankenstein, my Frankenstein fork of Lua. Not caring about crashes, point arithmetic, like string, like C string stuff, right? Like just comparing strings like a normal person, Boolean logic. So if that's a comma, next thing consume it, right? Like oops, why does this? All right, we need, and do we have an enter stuff? So we have type and stuff. Actually, so we need to store that. Okay, if that, so if they both are valid, then store argument. Like let's just accumulate them for now. Args. Again, prototype, right? Like this is later. We need much more sophisticated data structures, but like, so array of arguments of name and type maybe, or okay, let's prepare for optional arguments. Like if it's optional names, like if it's not a name, then that might be nil. So type more important. Again, prototype. Later more information needed. Have to go see you. See you too. Thanks for joining. Hope you enjoyed to learn something of my poor man's prototype. Okay, so comma. So then we need to so either we have type here. Okay, so either it's a neck type. So comma we skipped. Either it is closing parentheses, and we break a look at that. So let's see if that does something useful. Type is already defined. Statement things. Let's basically print our precious args of print number of args t comma n, or n comma t for readability, for human readability. So 1 is a int, 2 is b. Like look at that, amazing. Let's leave this stuff in here for next time's debugging or whatnot. Also, yeah, good. So next we need symbol lookup. If you're going to code that hurt what? Probe factory doesn't need documentation. It's right there in the name here exactly. If you're going to code that hurt decent, which setup are you talking about? Factory or that was a nice stream. Happy to hear that. So for real code, we need let's basically better continue with real code. We could, like, for this example, we could simply hard code it, but that doesn't suck. That sucks. Let's target generating more real code. So that means parsing all these statement things. And so next what we need to do next. So what we did so far, we tokenize our stuff. We did some language design of what do we approximately want, and we had that here somewhat like plus minus also. Approximately in this direction we want to go. Although actually, wait, this is still wrong. This was initially we thought like also like named stuff of right a, also I or int and size and stuff. I would also argue like if actually wait if there is not. I'm not sure if I would want a void type, but maybe, okay, it would need some type. Did I just delete that? Int I32, whatever. What random stuff did I hit here? Not really sure. Whatever, right? So in this direction we want to go, and so we performance tokenize the stuff. We pass some type def, some functions, some statements, some blocks. Not bad for 3 hours. And next we need this abstract syntax tree. Where do we have abstract syntax tree? So statement sequence, look at that, we already have this as a statement sequence. Actually, you know what? Let's start even simpler. Let's start even simpler in making that work, because for that we don't need. I mean, we could do int ab, but let's just return this number. That basically would be the most minimal. I mean, sure, there might be other more minimal things. By the way, also with brainstorming the stuff, I think we determined we probably want optional blocks, and due to an extension to that, it would work that you would have one statement functions, because statement block, right? Like to make that work for ifs. I would, as much, I agree with some people, but I want this minimal and stuff, but also like not intentionally limiting where there is no need. I understand some people want curly braces all over the place. But I myself, I can see the argument. I myself see, however, like writing simple if then whatnot things, I often don't type them myself. So while I get the argument, I also don't like such artificial limitations, right? And making ifs and else things work and stuff, it would imply like this block scope, block explicit block scope stuff would be optional, which would not be the worst thing. I mean, you don't need this often, but why not, right? And why limit stuff already in the beginning when you don't need to? So I wanted to set Codegen that, so that's the most minimal stuff. I would argue one function argument, so we have a function returning int test, so statement return a, so argue one type, where are our arguments? I commented them out. That's maybe not the most. Actually, maybe let's lock this function slightly different. If we maybe let's lock that all at the end for debugging purposes only, like for IA in I pairs args do. And if we write this in one line, we can conveniently comment it out. So that's an I. The name was second. So that's I, the number, and A is the argument. For such stuff, I like for debugging and stuff. My go-to is like one-letter things. For somewhat intuitive things is fine. To close and so now we log this slightly nicer, right? Like function int test. Actually, we could. Why do I log this like that? Because that function comes from there. Okay. Function int test and YOLO, whatever. So next we need, so we could start to Codegen that. Of course, for more stuff we need to pass abstraction 63. For this simple thing, we could start a Codegen. For one return thing, just to work on more infrastructure of passing stuff down to some machine code backend and write RISC-V definitions. And okay, we also don't necessarily need to. Okay, let's still log that for now. Here's the block, and like it's basically test hack Codegen. Basically for like now normally we would now work with this abstraction syntax tree, which we do not have. Maybe we do tomorrow or this weekend or whatnot. And for now, like we could hard code this for this one statement. We need symbol lookup, right? So return. So next we need all the infrastructure of dealing with literals, with constants, right? So we also need to parse numbers and stuff. Okay, what more do we need? So I have here some. Actually, so currently I've also like if people have a name like currently R2 stuff for our second, like after our Lua for our second language. Okay, so cursor track line number. Okay, read line number and file name. Why do I have here read line handle escape to okay YOLO? Okay, we have Pullman's. Okay, we want the macro like okay some whatever macro. Okay, tokenizer. We did here some tokenizing basic. Okay, YOLO. We need syntax tree, optimizer, like constant folding, dead code, yada yada, inlining, all the other good stuff. Next we need the abstract syntax tree to do. Also, okay, we need some kind of module system. The one thing I'm not yet sure how I want to do some module system. Some include module system things. Changing font breaks streamer command. You should change to the comic-based nerd font that includes much funnier icon characters. True trouble. No, I'm fine with that. If you want general opinion, extra cost added to the colon slice for the time spent same test function over the next necessary cases as long as it's optional. What is the name of the language? I don't have a name yet. Current prototype R2 because after my T2 Linux we need a. I don't have a good people there currently bracket guy. Then do your curly braces and welcome, Terrify. I would call it more Lure C++. If you've seen Alpha Evolve, not really. What's that again? Like random stuff popping up. Also, I just posted to our Discord today that it's weird. I don't know why changing fonts things Discord things so on. What did I wanted to say? Also things are going on. Okay, things, business. I posted today, I believe, or yesterday, that someone's comment. Oh, was it? Ah, it was an AI. As much business as AI. Like, in other words, all job cuts off by Google, Microsoft, IBM, Meta, all big tech directly result from AI investments. They have yielded zero returns so far while paying zero money. Original book writers, artists, journalists, open source developers, they stole their hard work. To compensate for that loss in AI management, came up with the idea to cut workers. Such a masterstroke. It's like here. I feel like what did you ask me? Google, what do you say? Alpha? What even was it? Basically, you need to repost. Microsoft going to fire another 5K people apparently. Yeah, that's why I always said stuff not the most amazing guy from you to compile modern for PS2, maybe worse looking case trying to afford. Good. So, is it over Discord? So I only wanted to say whatever. So that's also what I basically, I want a better future for all of us, which somehow not only all the programming languages are not amazing, and even Linux ecosystem not amazing, right? So that's what I, also AI not doing the most for me, right? So let's just focus on making the world a better place, one programming language at a time and stuff, right? So next, what we need to next we need to, from parsing all the statements, create a proper abstract syntax tree, like actually parsing all this stuff. Obviously generates a code gen. Parsing the abstract syntax tree, we need symbol lookup, right? Like, so basically we have multiple levels of symbols, like global symbols. We could actually, yeah, let's not test with that. Like basically global scope, function scope, nested function scope, and class scope and stuff, right? And that's what we need to implement next. Of course, for now, we basically yeah, how do we pass, like, no all the complicated programs start. I'm guessing it's a message object from message saying not lose your job to it, but lose someone, but will lose it to someone who uses. Someone said this. You wanna? I mean, light AI prompting fine, but also like at the end of like, sure, AI is just one tool, but of course the big mega corporations as usual do not do amazing big mega corporations thing. But yeah, also like, yeah, I mean, yeah, for 5 years, like if AI becomes truly general AI, then that's also what I said, right? We the world has no, like, basically we can only make the best. Sure, we could move to AI, but that's also why I do this compiler stuff here, right? Because we could also, if we do graphic subsystem, we need to JIT for old gen, like deleted at Mesa. We need to JIT, like, basically, hopefully we could make this so minimally universal that instead of Mesa, Near, and whatnot, Gallium and SPIR-V and stuff, like, have that also process here to generate ATI R600 things for our microkernel. But first we need to have some things working. So so we need to generate like, next we need to, I think the next like even to generate this one return, we need to have some knowledge of what even to generate. So we need next decisions. We need some decisions of like, maybe that is also why initially when we looked at the disassembly, maybe GCC. So because the question is like even return. Okay, so RISC-V, like RISC architectures anyway, can only return a register. So and that's also why I write this in Lua, because in my opinion, everything, like all the bookkeeping now, will be much easier in non-randomly crashing and pointer arithmetic Luas and C++ or whatnot. Yeah, formal verification AI, good luck. Also, this OCR disaster was only compressing, right? Like if that were like lossless compressed, it wouldn't happen. But like just like sure, if you lossy compress stuff, then yeah, then I might become J. But T9, I had to turn off my T9 since only happens at times. Maybe that is why. So we need some good strategy. So the problem is there are multiple things, right? Like okay, we have some decisions to make, even for this small example. Let's maybe, okay, we have here some bigger example, right? Like this was my truly minimal example. So for the next real code, like only on this channel, I need to make this. Should we spend a minute of making my Emacs darker to match VI? Like the only Twitch YouTuber not only running his own Linux, but mixing Emacs, Xemacs, and Vim. So I had here, what do I even, also like, hey, latest hyperlink. Usually I have a T2 background. Just don't have this because fresh hyperlink installs. So I have here some old 20-year-old Emacs. Do I have here default like orange and stuff? Where did I? Because people probably get pissed with. What was the other file? They are custom, of course. Here, background, default background. Look at that. Like maybe we do. Okay, what would be some dark? Look, do we have like dark blue, like really dark blue? Like what we have text is. What else do we custom comment phase? Background light, what is it? Class background light, grayscale, class grayscale color, background light, common phase, dark blue, secondary search modline widget, where do we have text color? Background, why do we have another default? Why do we have another background? Widget field face, grayscale color, light, gray, dark, dim gray, italic T, nah. Let's hope this thing has, like, I actually, maybe we want some dark magenta, right? Like, or dark indigo. Where are this X11? Which color name stuff does this even use? Oh, that's a little bit, yeah. I mean, do we have like, does there X11 colors? Do we have like some X11 color names? Give me some. Where is, yeah, okay, here we have, does it have Rebecca? Look at Rebecca purple. Are these all the bloody color names? Are these freaking all of them? Seriously? Like gray. What did we? Gray 888. X gray 888. Ah, here is grade 8. Shades of gray. Wow. Numbered variants. Blue things of gray 100. Okay, that makes. I mean, what is gray? Did I have gray 888, gray 41? Defines 101. Who defines 100 freaking 1 shades of gray? Freaking. Okay, gray 0 to 100. Like, seriously? You had me at 100. Okay, let's maybe make this simply. I'll only do this for you guys. Gray 88 to gray 8. Then I need to change here less. And where do we have default font? That obviously doesn't fix the thing here. It still is unreadable. Oh, that's pretty dark. It's probably how dark you want it, right? Oops. Wait, why is this capitalized? Yeah, we continue in a second. Wait for it. I just want to make. Yeah, I mean, I only do this because people, like an hour ago, people like, yeah, blinded. I should have done that. Okay, that's somewhat detailed later. Okay, so only we need to make comment and stuff. I mean, maybe I should use Emacs, but can we read that here? Or where was it? Edit. It was somewhere customization, right? Let's see if we can make this here in this instance. Where was it? We will continue a second. Just need to dot file that. Ah, yes, customize phase. Where is even static in continuation? Like, how does it stuff inherit? Green GUI button phase highlight. Where is the bloody default text thing? I hope even Emacs can do that like that, can it? Widget phase. Where is bloody text? Functionality. Which one? Where is the bloody main text? Blue, bold. I'll let you find. Green text, I search, italic text, red text. How to make X Emacs white on black dark theme. They have Emacs here. I mean, I could switch to Emacs to make my life. I've seen. I could do this later with my beloved Primer X Emacs out of my cold dead hands. I'd seen that one here somewhere. Wait, what? Why is this so stupid? I think this has theme somewhere, right? Like the Emacs. Just so that. Or I should just switch to default font. Where is custom themes? Custom themes. I had tried. Maybe we should just use that save theme settings of. I thought I tried this earlier today. Was there one nicer? Which one was? Which one is the nicest? Here's dark. Okay, that's not wheatgrass. But whiter? Whiter. Deep. Okay, you had me at deeper blue, maybe? A little bit low contrast in case that is. Unusual dark. Like, can people not have a proper. Why is things still. I mean, okay, maybe I shouldn't use Stone Age editors. Tinted. Okay. I think the save didn't work. I hope. Set default font to comic. Why does this not select all? Are you freaking kidding me? Which one is it even? Can't see that here in full, not regular. For you like that and select, and somewhere there was options, save options. Does it save that? Cannot save customization init file was not fully loaded. What the freaking heck? Save is undefined? Type red or click on enable disabled type theme failing custom load parse. Why is stuff always so intuitive? Menu by options save. Oops. Cannot save init file. What is this shit again? Like why? Why is this so shitty? Why does this not just, I mean, yeah, so much to dot file. This is usually I don't touch this much. But if I work like for a week, I should make this dark theme to make you all happy, I guess. Loading battery done. Did it save that now? No, it saved that. Let's see. Set default. Let's try this again. It's a little bit large even for YouTube. Twitch. Does this save? I really hate when stuff always cannot save. Init file was not fully loaded. What the freaking heck? Alright, I'm not logged out. Didn't log in shit. Theme gallery and how to save this bloody freaking theme. Why does this not just work? And cannot set default syntax theme even if loaded. MX disable theme, customize theme, things, edit, fixed, help, question, Emacs cursor, colors different, what? Fixed using the help from this question. Might be UX resources. Customize, freaking killing me. Apparently it solves the problem here. Is my rest. Wait, what? Apparently no init file solves the problem. Here's my Emacs rest. What the freaking heck? Freaking kidding me. And I've set here. Okay, I have some Emacs init el4. Alright, this is. So if you have that, you can't set or what? That's okay. How to work this recipe worked. All I wanted was dark theme. What happens if I like this is why you even need to write an own editor. Everything we need to is a great reset, everything new again. Just if we didn't waste our time with bloody dark mode customization. The save option didn't work. The save option returns the error of, okay, now it wrote in .emacs. Maybe it didn't work because, let's see what happens. maybe it didn't work because we had an init file for stupid Emacs Lisp reasons. How should I know? Custom themes. Which was a good one? Also, was it that one? Ah, we had tinted, right? Like we had some tinted thing of, oh, not light blue. Oh my god, who makes such themes? Who makes here's tinted models? Vivendi, no documentation. Yeah, okay. Does that custom save future sessions? Okay, let's see. Did you save something? No. Hey, you saved something in the futures now. Wow. Okay, we can finally continue. Finally can go back to code. So that you don't get eye cancer when I switch you between things. This was probably this one here, right? Like here, source JIT x Emacs of Emacs now, parser to, okay, test, we moved that, that's no file for tests, test new. Now we're back in business, look at that. So what's this garbage here? I mean, okay, now we don't have Lua mode. Actually, I used Emacs because we have only Lua tree setter. Yeah, wonderful. Okay, fine, YOLO. Now you get dark mode, but no syntax editing anymore. I mean, I wonder. It was like even the Emacs shit sucks. Like, let's rebuild Emacs because why not? Let's build tree setter. Let's see if tree setter does something halfway reasonable with our Lua fork. Probably not. Yeah, so yeah, apparently the save option doesn't work if you have a custom init EL. It's like Lisp file for Lisp reasons, whatever. Yeah, not the most intuitive. It is what it is. Currently, it is what it is. I don't have the highest hopes, but we will see. Yeah, all the mods. Yeah. Okay, so all we wanted was Codegen, except now we need to restart Emacs for maybe. Yeah, let's see. Yeah, I know. So, buffer. This bloody X Wayland. Well, how many do we? Hey, 30 FPS while building that? Maybe. Where are we now? Have you looked at the? Yes, not liking it. Don't us like. I also like way too large and convoluted. Okay, so we want Codegen. So when we looked at the assembly previously, so what we need to decide how should our compiler work in this internal object tree representation. And that might be why the unoptimized GCC code was so horrible the other day earlier. Also, like now we probably have dropped frame. 20 frames with full load. It's a Steam Deck, thermal throttling and stuff. Yes, I'm developing livestream from a Stream Deck, right? Like highly efficient T2 things. Boo, the top of 1, 2 players. Because we certainly don't want to program that. So let's go to some test file. Because certainly we shouldn't write Codegen now for one pathological example. Let's maybe illustrate this on this one. So of course we could look. So next we need to Codegen, right? Or build the syntax tree. So what do we precisely need to do? we need to map, so this is in a register. The question is how precisely we certainly, so we in production code, we nearly never have a value direct straight in a register. So this is basically, basically register calling convention is an optimization of writing everything to memory and reloading everything from memory slow. If everything would be in memory, it would be easy. Everything would be like basically would be reduced instruction set minimalism. But reality is we want stuff fast. Because what is the issue? Usually, so here could be everything, right? Like here could be 1, here would be floating point thing, and another var, like in a real function here. So here would be C, right? So instead of, I think what we should do, and that is probably why the unoptimized GCC code is so horrible. It's like, yeah, shared files of YOLO. Let's just reload that before we do more. Save, yes, whatever. Let's see, do we get here any tree sitter? Also, so this somehow doesn't work for reasons. So much to building this stuff as tree sitter, and then modern shit doesn't work. Okay, it doesn't have lure here for reasons. Wasting stuff with dot file, maybe we tree sitter grammar lure built inside neovim configuration. Okay, that made so much to have. That is why I was using Xemacs. It did syntax writing without tree sitter for 20 years already. The future was now. Okay, YOLO. So I was at special case, and we obviously should not know YOLO code for pathological case of returning a register, right? And this register calling convention is already an optimization. So we could basically return everything, right? Like if we would have, like we could have one in global, and we could return global, right? That would need to load the global address, like also with relocations of dynamic address determination of shared object and whatnot, and load address stuff. All the other complications later. And it could be local, right? So what did we have? A here. So this would be local. So how should that even work? So even that is a special case. Like if we would have global, we could have like global plus whatnot. So that would need to load the global and stuff and store that here. So how do we best? So what we need to do is, so we will Codegen and optimize based on SSA, single static assignment form. And what that means is like every computation, like everything is const internally, everything internally is const, and it will make it create an internal temporary. So internally that should generate some assignments, so that should be a1. So internally, right? Like so internally, like local or whatnot, a1 equals a, and then local c equals a1. So that's what this internally this single static assignment form does. Every operation with that creates a new temporary. I mean, we could also like probably just basically it doesn't need to be a1, right? Like we probably usually also like it could be 1 plus, like basically probably we just call all of them t number tn. That would make more sense, right? and Z here would then A plus B. Yeah, yeah, whatever, right? But so we need to support multiple things. We need to support constants here. Lua calls them constants. They could like literal immediate values. So basically, we have a lot of stuff to do now, even for most minimal things. So as per usual, the beginning is always the most difficult to create some new structure, some new order in this chaos here, and create some nice code infrastructure to work with all of these things. I would say immediates, to make stuff simple, I guess we should store simple, like we should probably load, like again, so we want to keep our stuff most simple, right? It's not fun to like check everything, like is this an immediate, like is this a var and stuff. So I think what that should do is, so like usually we have like symbols we have, right? Like we know it's coming from somewhere. So it's we know where we get this. So immediates is different because we would internally we would also need to load immediates, right? So to have the most simplified code flow, the most simple to use ust to work with, I would argue like all constants would create local vars, right? So that if you write something like this, like maybe even, and that's maybe something similar to what GCC does, because like the unoptimized GCC code, actually maybe we look at that again. Let me just power on my Ryzen workstation here for energy inefficient reasons. Also maybe I should check any important emails. We're working on stuff for 4 hours. Oh, look at that, got some emails. So unoptimized code for that in GCC was crazy. And for just this simple file of this is just what we were working with, int test, like int test functions that returns int ab return a plus b. So that is all what GCC does for that. It's adjusting the stack pointer 32 bytes. Why does it by the way by 30? So that is immediate. It stores, so it stores a frame pointer offset 24. I slightly, or is that hex? Is that hex by default? It's so strange numbers here. Oh no, 20. Oh wait, 20. Oh no, this okay. That might make sense. Okay, because it's, I was thinking bits somehow. Of course, these are bytes. This is why this was confusing me. What do we have here? I and 8 at I 32. So it's moving even the arguments. So it's saving the argument registers A and 1 to A4. And then it's even saving them. I mean, this code here is crazy. Like, why? This code is absolutely crazy. I mean, if we generate algorithms, they might do similar to crazy things, but this is just so vastly nah. the thing is, what do we do with our actually we did say okay, earlier I said, so I was thinking like maybe we should generate temporary arguments here for all the things. So because, but that's also why you need to have some plan and team and work, like certainly design document and other things, right? I forgot already my own goal here, implementation strategy. I said actually we should, in my opinion, we probably should work on, does it even make sense, registers? So earlier I said like let's do everything in registers. Does it make sense? I mean, I would argue, I mean, we could also read papers, right? Like the go-to thing in a university would know to read papers and study and stuff. And would the language have a preprocessor? I don't know yet. Like, let's first do some code. Let's see what we will probably try to make preprocessor template things more native, like more native integrated. But we will see what is the easiest and most reasonable and stuff. So there are multiple main, like of course the possibilities are endless, but main strategies would be to work only on registers or work only on memory. If we were to work only on memory, we would need to save A and B now. But maybe I would intuitively expect we could generate slightly better code, as I initially said, to work with virtually infinite registers and let the later register, so what a register allocator does, like in any case, we need a register allocator because any CPU has only a limited subset of like maybe 6 or 16 or 32 or 15 or 31 with 0 register, always 0, plus minus other stack pointers and stuff, so in reality less usable. And the register allocator would need to allocate registers of like what, like load, store, what can we keep in registers and stuff. And I would hope, so the two main strategies are either save everything in memory, like work like basically with some accumulator kind of thing, like load, do stuff, compute, store, like an 8051 or stuff, or probably only had 2 registers or whatnot, A and B, or like the good old 70s first microprocessor things. Only having some A and B accumulator or other such things. We should always keep in mind to make stuff as simple as possible. Always loading and storing everything in memory. The Java VM has proven that is like basically stack-based VM, super freaking slow. I'm kind of tempted to try to go with keep everything in virtually infinite registers and then register allocate. Like obviously if a function needs more than, let's say, 32 or 64, 2 to the power of 32 or 64 registers, then throw exception, error, function too big. And in the register scheduling, spill to memory, right? Like, so basically that like everything is in register, like for the SSA single static assignment form, so that the question is only what do we do? Like maybe internally we generate like local like basically generate here like just assign this to registers, like save and optimize, like or we treat all function arguments as, so like either we would need to copy them to have them all in virtual registers, like basically as a +0, like just to have them here in some regular form. For the register allocator, and obviously we later need to optimize everything. Yeah, Lua stacks everything. That is true, which is why we want higher performance. But also Lua Lua, but only, no, actually that's not true. Lua only stacks function calls, not locals and stuff. So wasn't it like Lua faster because register based? Like also like basically Lua only 240-ish local vars and stuff. Anyway, so we need some implementation strategy. Either we save everything to SSA internally, so that would be local T1 equals B, and then like either like T2, like what, like T1. So the reason to save that would be to make sure we don't clobber this, right? Like basically just to unify the code path here, like basically function prolog, store and load everything to locally later allocated and dead code eliminated and stuff. Is that Hyperlink? Yes, we are running Hyperlink. And by the way, we run everything on latest T2 Linux. If you're new to our stuff, of course we do latest and greatest stuff all over the place. Latest OES, latest everything, latest literally compiled yesterday. And by the way, is that not transparent? Okay, only this is why. Okay, I mean, this window not transparent. Okay, YOLO. So I'm only brainstorming, right? Like, if any compiler engineer throws up already and has better feedback, then. So what are we coding today? We are coding a new language because all the languages suck. And all the Codegen. So, and then that return would basically, so if original function, so I'm modifying, so that would be T2, right? And then optimizer would work on. So of course, this is the most minimal function. Like usually we would have much more stuff, and like we would usually have hundreds of temporary things. And then we would need to code gen like line by line to machine code and register allocate and like spill like load and store thing. Yeah, we have a freaking lot of work to do you all. What you use 256 limit for local? Of course not. Like this is a toy language, right? Like we want a mission critical language. Like this would be this is only a Lua bytecode implementation. Our stuff would be only limited by available memory and like 32, 64-bit things. So like you just code. Like, of course you need some bootstrap. Like in the 60s, 70s, people wrote new languages from scratch in hex machine code. But I made myself Strata 42. Bedrock, Linux, T2, T2 models. I need to figure out how to keep it from freaking up. Happy to hear that. So I've chosen to use my Lua fork, which has some Luaisms edited away for more modernism. And we truly write everything from scratch. Like we will, of course, we will not use Lua as base language for long. As soon as we have reasonable, stable stuff working, we will migrate that. We could also bootstrap this in C. Like normally people bootstrap in C or whatnot, but yeah. Good. So I'm only brainstorming here. So this looks reasonably. This makes some sense, right? Like basically, so how would be, so this would be all temporary registers. So if there would be a store, like let's say we have here some global, like int, that doesn't matter the most, like YOLO, right? Like some global here without typos. And we would assign that here. Then we would have here, for example, like this global like store T1, right? So then it would be flushed to memory. If that would be something that I would say that is how that should work. Similarly to other, so these are basically if you assign that to Yeah, basically all assignment, like where, so all the assignments here would be local temporary values. So what does it, and so only other memory things, like, so if we would have, what do we even, I mean, so local vars are basically not visible. So like all the local vars do not necessarily need to be in memory unless parsed to a function by reference. We need to see. Do you plan on garbage collection, like only in the core library? C is a very good base from what I understand. Like, no, C is horrible. Like, I intentionally do this in Lua to prove like you can write new Lua in a new language and everything. Declare volatile the global. Yeah, maybe we will see. This is just, I'm brainstorming here for my static assignment form. What we probably should do is draw some nice graph. I just don't have my graphic tablet with me. Where is AST things of here? Conditions, while condition body var, like compare. Yeah, so this AST becomes complex soon, right? Okay, so we have here while b if stuff. So is that here? I mean, probably so. Statement sequence is the whole thing, right? Okay, while next. Okay, so that is basically how that works, right? Like, so if we would have the next while loop, then we would have statement sequence, while all of this stuff, compare, branch, condition if body else, like this one here, like this is a branch, like however you precisely would. And so if you would have the second, then it would continue here, right? Like only here the next, so that's the next statement. So like that statement, right? Like and return var name a. But it's just what is T2? T2 is one of the, did I not post that is one of the most amazing Linux distribution ever. It literally opens the website when you click on it, thanks to this triple www invented hyperlink amazingness. Okay, I guess we don't see Codegen today. Next, I would say we really need to, like, so what does that? So basically abstract syntax tree. How, like, the question is, what do we optimize on? So basically we optimize on the tree SSA form and then generate code from whatever is left from optimization, right? So originally I should have left this here original for comparison sake here. So originally we had only did we only had a plus b here, right? Okay, we can also break that. So that's what we had here after we a plus b. So that's basically a quick initial look what a compiler needs to yeah, we are shadow banned by mainstream media. Like, it's freaking a lot of work to get known. And even if you're known, the mainstream media, like, nah, I never heard about it. Not really, at least not only one compiler thing in such a C doesn't check like the piece of flex with average goal among those things. I think of the poor guys opening a thousand. What you're talking about? What you even talking about? So R is a parser. Okay, so so I think that, so we basically have at the end that, so how would the abstract, so we would, for this thing we would have so first we would have that here. We would have a bin opt opt minus var is sign. Yeah. Okay, so we would have Okay, that doesn't have an assignment. So basically what that the S should look something like, so that's plus. And that is why this Lisp stuff is often, or other internal stuff is often written. It's today's maybe time for a break. Is it even? Yeah, a lot of internal things are often written in other ways. If you're wondering, like, why is internal stuff often written? Because like basically the important thing is what freaking is that, and then with what. So SX, like basically here like list and stuff. So here plus, right? So that's basically why stuff internally is often represented differently, because yeah. So A plus AB, right? And then return I would even, so internally, so that would be we need some way of maybe that's producing T0 or whatnot, like somewhere we need a single static assignment form thing. I could do this at first, but maybe not everything will have an output. So like basically plus AB to T0, and then this would be return T0. I would say that probably should be approximately what that should look for is a T2 for you might look on the wrong website. Some unfortunate people created some, like basically also if that's confusing me, our old website is T2 SDE. Because system developer T2 is for freaking, it's the most universal Linux distribution supporting everything and SGI, and like it's the most CPU architectures, everything supporting. Like just Apple came along and called their stuff T2, and then hobbyists the T2 Linux org. People do confusing things. So so I think this is how this should work internally. So if we have more complex, and then it should generate probably some, I mean, yeah, there's still some implementation details of like, how does it know where stuff is coming from, to be honest. Maybe for simplicity, we might generate like basically assign, like maybe we do assign a T0 like automatically. Maybe we do an assign for every arc just to have uniform stuff for the register allocator. And then like this would like this. Like I'm only brainstorming of how to make, otherwise we would need to hard code what comes from where, argument memory and stuff. That might be more annoying. So that might be how that would look like. Is that what I have here? Local T1 globe. Okay, this is just an example. T2 equals and so then if we generate that trivially, our register allocator would move A0 to a temporary register and stuff. That of course would suck. So basically the optimizer would need to optimize it away, but we only have that for function calls. The thing is that it is more complicated, right? Like because we would probably want to implement this like to minimize bugs and symmetry and loop code invariance. We probably, it's based on Rock Linux, but I do this for 20 years. But I'm there since year 2 or so, or year 3. I'm there since the early days, and so Claire Wolf started this in 1996 or 7 or whatnot. I'm there since 1998, 1999 is. It's only based on Rock Linux. Also, like I've already done a lot of half of Rock Linux, so with Claire and others. So yeah, it's kind of it for continue, like it's basically based on nothing else. It's just a renamed fork continuation of Rock Linux. not to confuse with Rookie Linux. Or, anyway, okay, so this might be because we more complicated because depending on the architecture, we have only so many things we can pass in registers, like even RISC-V, 8 or what it was. So we would need to have a sign, like basically, how do we like do that? Like basically like load, like, so there some stuff will really like be complicated. Like, hey, writing a compiler and backend from scratch, complicated. Because we need to, like, if more arguments, we would be passed from stack. Okay, so we have that stack. Okay, so everything is guaranteed on the stack. So we could still basically assign that, like, basically, like, memory, like, load, whatever, like, however we call that, stack pointer. That is why there might be more, right? I would argue it's probably best to just internally represent that and optimize it away if unused. I mean, usually it will be all used anyway. So why? So terrifying. I said this 4 hours ago and weeks ago. So LLVM too big. I want something 2 orders of magnitude smaller than LVM and stuff. The problem is LLVM too large. I want truly minimal stuff. Like, even if we only reach 90% of the points, I'm so thick after 25. Speaking of maintaining Linux systems for 25 years, I'm so sick and tired of all the complexity and bugs and features and unmaintainable stuff that I've like. That is why I want to prove that you can write minimally, beautifully, keep it stupid simple. I probably actually should write this somewhere. That is why. Message thing. So where is my here somewhere? Like we basically need some language mission, right? Like where did I wrote the other things of as Codegen? Where did I write? Where did I write that down? Minimally beauty. Simple whatnot things, right? I want this. This is basically you put it in Parse toolure, I think. Is this not Parse toolure? Where did I not save that? Did I delete that? Did I move it somewhere else? Maybe I put this in. This is Parse 2. I probably put it into lang new, or here I put this here. Here I put this. So what did I but thanks for the reminder. We also need a name. Should we rename this? Name this R2, like the running gag of my 2-letter product names. I have not a good language. R2, like Pluto, is like, I don't even freaking like the most, like Pluto only because like Lure, like the most minimally beautiful, simple, portable, readable. It's like, and that is not LVM, right? Like horrible code base. I like, and that is also why we will not be doing that in C++. I'm from, if you don't mind, I'm from Planet Earth. Things. Why do you ask? Where are you from? And why does it matter? Okay, we have still a droplet of coffee. Damn, and everything exactly. And you? Probably from Pluto. Everything is so freaking large here. Like everything is so freaking super sized. Okay, Codegen. I probably where did I in FN? Also buffer. Was it test? Oh no, it was FN. Okay, so basically we can change this later at any point. Like basically all we need is some reasonable, usable base infrastructure. And then like if we have more than 8 arguments. Western Asia. Where is it? We need to know. Did you say that last code and the minute code? What did you say that last code was there intermediate? Which last code? aka some Middle East. Okay, happy to hear. Also, I'm currently more west from that, if that helps. So, which code is what? So of course, this are the kind of stuff. What do we do with memory references? So basically, all in virtual. Basically, we compute everything in virtual registers. So we need this anyway, right? Like a global. If we would have a global, we would prototyping everything in registers is fine until you need to have I/O, input and output. So global, basically it would be some kind of load, right? So colors, everything. Do they have here? So they don't even have, they have just var, they don't even have ref, they only speak on, does working on var references make sense? Maybe in the, actually we could, okay, so given the language is not really assembler register based, we could probably work on symbol names instead. Have a good evening there too. Basically, we could basically make that work on symbols only, and then lower that to registers. Maybe that is how probably usually it is done, right? So then we wouldn't need, so basically, so then would be a symbol name. Then actually the us would be slightly, okay, if we work on, so basically we don't have registers here. Okay, so we would lower AST to intermediate, right? So that would be IR. And then we would have move, load, store, sub, add and stuff, right? That's probably how we do it. That probably makes somewhat sense, I hope. So then we would have T0 plus A B producing T0 and return T0. I kind of like that. The only complication is so, and obviously then like we would have if and stuff, and then we would have multiple trees, as in this. Just don't want to ASCII graphic that much here, right? Like you get the idea. The only thing I didn't yet make provisionings for, so if we write like in high level, you can basically write everything, right? Like you can have memory map, memory mapped shared memory, even with hardware I/O. Maybe we need to, or like not maybe, we need to declare some stuff volatile, of like really writing to memory, because memory mapped I/O things, IPC and stuff. If we write, like not if, when we write in kernel, like basically we mostly don't need assembler. Like for all the high level stuff, we basically don't need assembler, except if we wanted to do cursed optimization stuff or other trickery. The main use for assembler is, of course, operating systems and bootloaders and stuff. And as the Linux kernel shows, or other portable Unix clones previously, you don't need the most assembler, right? Like just have everything volatile, and like you only need assembler. So I only say this, like basically that is a high level picture. Let's more Codegen, like what else do we need? I don't have the super amazing idea for that yet. I also didn't brainstorm that yet. All I'm saying, so of course normally you shouldn't do assembler. Just write this whole level code and high level code, and it will be amazing. But sometimes we need to do assembler. And one thing so if we do a preprocessor, it will not be as garbage as C, obviously, right? Like with everything needs to be one line and like define it like text substitutions, so like just silly. Similar, all the C assembler stuff, of course, sucks. I don't have a super like how does Rust inline assembler? What can we learn? Unsafe, ASM. Oh wow, they do this like GCC support inline assembler is provided ASM. Okay, standard Arch ASM. Okay, so they basically copied the GCC template. It's or is it? Or maybe not. It looks close to GCC. So if you don't know, like the GCC template assembler stuff, like at the time in the 90s or so, it was a novel feature of at Intel or others. You had, I probably did that like in the 90s in Turbo C or whatnot, Turbo Pascal, Jack2. So this looks slightly better. I believe in C you often have tabs here for maybe, or I don't know what do we even have, like temp is stable. So actually they only have assembler for a handful of architectures. That is funny. Our use case is slightly special because we want this intermediate representation thing, and so our backend will not even support, like I will not write a universal assembler, probably, famous last words. I don't even want to assemble all the current gazillions of 100,000 of x86 instructions. Borland, yes, back in the day. Can't remember. Yeah, Borland stuff of back in the day. Using inline assembly in Pascal. Yeah, it probably was hard coded. Like it wasn't as template matching things of modern GCC things. How did I remember that slightly. ASM and yeah, okay. That makes some sense. Okay, straight, like how does it? Okay, so it has symbols. Actually, fair enough. I mean, so I mean, thanks for this. Like this. Do I have still a memory? I've a manual I wanted to say. Okay, also doesn't matter. So actually I like this. Like they're here. The future was there. It's like, look at this nice DOS assembly. So the only problem with that is that the parser, like this is not like that's not super nice for the parser to have like ASM custom mode things. But like, hey, this is how amazing it could be. And like GCC, like so much time of my life I wasted making GCC template stuff, groks this shit. So we don't need the most assembly. Even Linus Torvalds has written 99% of its code in C for good reasons. And we will, of course, write 99.9% of our code. We need only very, 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 very little assembly stuff. What do we need assembly for? We need assembly for, like, so ASM. Okay, so ASM, AMD, ASM, and it's like, yeah, what do they do? They do ASM, so it's probably some macro fiddlery, right? We will see. I only bring this up because we are in AST Codegen, and I mean, if you truly wanted SSMD vector assembly, you could still use another compiler and link it together. Yeah, also I don't want to like vector assembly stuff like that. So we need to use it for like for stuff like model specific register, like read model specific register. I think it was that, read write model specific register or variants of that, like hey CPU ID, right? Then like load global descriptor table, load local descriptor table, or load interrupt descriptor table or whatnot. like for such stuff, right? And that is usually few liner, like also like risk 5 cache, like flushing, like other architectures have like membar, like PowerPC and stuff, right? Like basically like MIPS of like membar things of whatever their names. Unfortunately, debug specific doesn't define an explicit standard way to handle instruction case. What do we have for? So probably for risk 5. It's like this document somehow didn't search nice in my freaking browser for some reason. Oh, this is also calling convention. That's the wrong document. So we probably, like, given we probably don't need this crashes. Congratulations. Hello. So this is unsupervised, unprivileged. How did I close it? Thanks for the subscription. Highly appreciate this. 10 months, man. Time is running. Finally, we do things. How about SM? Yeah, some kind of standard thing. So I only bring this up now because we need some way. So our language will parse this stuff, build the type information things, build abstract syntax tree, lower that to IR, and then JIT or Codegen, like JIT or ahead, often JIT, but otherwise ahead of time, Codegen that. Intermediate, I showed that earlier. Intermediate IR will be, do I have this here? It's another document. Maybe I should have that in one document somehow. Where, yeah, here this here we actually I need to copy and paste this in proper order. So yeah, obviously parse, tokenize, parse, oh, yeah, ASTZ, IRZ, and CodeGenZ. Basically like LVM and stuff, right? Just more tiny, more readable. I mean, initially we don't need assembler. When we need assembler, we hopefully don't need much. Something of what you say is of course reasonable, but I'm only saying readable. The only question, I mean, yeah, obviously it will probably look something like this Rust stuff. The reason, I mean, it could just be like, why is this not? Maybe we may also make it _ ASM, but hear me out. So I mean, this is also like in-out register. Do we? I mean, maybe sometimes you need register, but can we not make it like? I wonder if it would be possible to make possible. I mean, first we usually have like single instruction things, and do we have a read time? Read is it read timestamp count? Is it RT? Read, is it that? I forgot. So usually we will have one instruction do this specific low level thing that we don't have. Maybe we do some. So obviously I would not want to support any instruction. For the ones we need to support, like maybe then something like ____, like just to say, I mean, we could ASM. Like also it does basically not matter. Although ASM is 3-letter. If we do like other languages of like, we could somehow do that like a code block, like to have like basically parse the whole thing then as. So here, this is a little bit funny. Like maybe I wouldn't necessarily do that like that. Why is that even? Maybe, okay, because these are arguments, right? Like probably just because it's a macro. And that is then like single text arguments, although that is a little funny. How do they do that then? Whatever, like I would just like not use ASM. It also doesn't matter, of course. And then make this go into some special like passes specially of like so that we are able to, because it is just what that does is also a lot of basically text-based replacement, right? What do we have for the inline thing? Does it do any parse inline syntax according to set of still planned? I think it's still planned that SIG assembly is going to change. Custom assembler is still on the table. Everything major area of focus at the moment. 2020 series would like work on this. This is probably space for innovative ideas. Parse inline is according to set of dialects integrate inline with the ZIG language. Currently we have inline assembly is comp time, known strings that can be built with, such as stage 2 inline assembly must be string literalized. Preparation for the proposal here is what inline assembly looks like today. Arc C pointer. Why is this commented? Why is this looking so shitty? Are they series? I don't understand. Are they? I don't understand what. And that is what I hate with cursed syntax, where you don't even what that even. The proposal is to introduce a concept of dialects in the first place. Exactly a standard target CPU RG but it's dialect specifically integer token. So this 6-stack comments like break can be make up or something. So this backslash is really what they freaking mean for that? Are they who? So this is their bloody syntax, like, and then it's like, what do people do to come up with this shit? Like, I want, like, why? Okay, so all I can say is it shouldn't be that cursed. And yeah, I mean, obviously for the kernel, we need this. We should not initially optimize for that, but we should allow some possibility to not make it that hard to implement. The only complication, the major complication is that we target some own intermediate representation. I mean, the question is how does LLVM? I mean, for something we could do like like stuff that exists for most architectures. We could have a custom, but it doesn't solve the general problem. Handling inliners in Clang and LVM compiler infrastructure. Look at that, 113 pages. Oh, that is someone's nice representation here of inline assembly. Introducing inline assembly. In some if like else things, movable things of, yeah. Inline ASM start inline trials and critical 113 freaking pages. Nah, you had me 100. Okay, we know all this stuff. I mean, I know all this stuff. So how is this in IR? How does the IR look like? Somehow everything is too complex these days. Move dash. Look at this. Okay, what is it? Move the machine. Yeah, so that is their internal thing. What if in some way, shape, or form you would need to write our internal, like you couldn't write. I mean, yes, I understand it's a little bit annoying, but we also need to make stuff useful in the context of our most minimal implementation, right? Again, we don't want, like, because the problem is if we allow arbitrary assembly, we basically need to write a whole assembler, which is exactly what we want to try to avoid, right? What if, like, usually you can get by most, like, basically we only need the stuff for really special stuff, right? So usually our stuff would be like move, whatever our precise syntax here will be, like something like that, right? Of whatever I had there previously, like move and okay, just load and stuff. But mostly we need this, and then you would, like, time will show. But so we would need that, like, basically read timestamp, like nothing, like basically maybe we make this, like it's not our stuff, like maybe like something like set like risk5 or underscore or stuff of like having like targets. I mean, we could just read timestamp counter. Timestamp counter RDT times read time or arch here is like maybe maybe this, maybe whatever. And then our register, right? Like basically read that. However our register, basically mapping, and then what are the, I mean maybe just underscore something, like just to signify like you are leaving, like not generically supported, like either that or like set dot, but that's a little bit annoying, huh? Or maybe just underscore, like just again not important, just like, so our stuff will be similar, just like basically not using like IS, like yeah, of course doesn't matter, but like why not make it nice when you can. Where do we have risk5? So I mean unprivileged should this have some counter, right? Like, is the search really so shitty? Like, what is bloody with this? God, just don't understand the vector count, pop count is draft. Wait, does it? Is there not a bloody counter? Ah, yes, also fence. Wait, what does increment version number things, fence I counters, vector count or cycles? Was it cycles? Atom cycles, clock cycles executed. Read cycle pseudo instruction reads the logs and bits of cycle CSR which holds. Yeah, so read cycle here, for example, I'm just like basically read cycle and other such things, right? Although maybe we even have a pseudo op for read cycle, like mapping that portably to any, but all the member things and prefetch and what would be other privileged things? Yeah, hypervisor stuff, right? But what most of those things are just set internal state and so on, right? And similar such things, page table, memory management things. Just give me CSR. Yeah, read the CSRs. What was it? Stands control instead like CSR. Member. So basically RT is CSRs. So it's similar, and like of course they all different in all the hardware, like ISOs, PowerPC, Spark. The concepts are all the same. Yeah, so a lot of stuff like basically for RISC-V, like for RISC-V we mostly need counter and read-write CSRs, hypervisor status bits and whatnot, and probably some pseudo instance like counters. Yeah, the devil is in the detail. I mean, M status register read writes like here. It's just what is it, CSR? Where are we? We are at 220. I mean, it's crazy how, yeah, I mean, sure, we are 60 years into the computer revolution, but things are so freaking complex, you all. Fun when we write a microkernel for RISC-V. Yeah, such kind of things, right? Like that is why we need this for, like, basically don't assembler unless you read write control and status registers. So we might have counter, but I mean, this is just read write, right? So that would be then read CSR or stuff, whatever that was. I think it was something like that one. We just need to supply. Yeah, we basically need a similar mechanism like all the other, like, as much as I hate it, for like whatever register we have free in. C hash assembler causes move and then allocate memory right as m function there and return function pointer to the first. It's run natively. Interesting. I mean, I basically know how all this works and stuff. It's just like basically the great reset project of rewriting everything from scratch. What could possibly go wrong? I need to start like, so next so what we need to, like, we showed some initial stuff as usual, like, yeah, writing a compiler language from scratch. Sure, it's a lot of thinking, like you need to think this through, like how do you want your syntax and stuff, like what do you really want. Of course, nobody should write assembly, like this is only for debugging, breakpoint stuff and operating system things. Thankfully for most, like for all hello world example things and stuff, we don't even need that. I only wanted to say, like, further complications, there are things. And I think most things, yeah, famous last words, we will see. Why do we have there? To accelerate this, so I obviously cannot do that alone. I can write some language here, and like other people, like Roberto from Lure and others did. Also, Fabrice Billard. Is this an impossible task? No, of course not. Fabrice Billard has written multiple, like probably in the meantime a dozen amazing projects, including QEMU, FFmpeg, like TinyGL. Did I say QEMU? And other Java, JS, Linux stuff. So maybe even BSIP2 or whatnot. Other people have done amazing things. Although he has abandoned most projects, which is also amazing. Making also, like, what ball of steel's award of like writing amazing projects. Like, yeah, okay, I'm done. Like, other people can maintain it. Like, right? Amazing for open source, of course. But I mean, to be honest, like, it's also like maybe not. That looks so more silly. YOLO. So is it an impossible task? No, of course not. Especially like we target reason. Like, this is why I don't do C, because like C cursed, and this, like, we are much more free to implement more minimally reasonable sane things by us. Like, now we don't like it that way, and it's hard to path that way. And obviously, yeah. If it's hard, we can just skip it. If we don't like it, we can just do it differently. And I hope it will be amazing. The good thing is we don't need to be compatible with anything. And probably next I should set up a dedicated repository, because currently I have this in some 10-year-old cursed random example repository. I should write down some kind of example code, like as much as I hate it, but we probably should do that early, and maybe not, maybe here. As much as I hate it, we need some shameless self-promotion to attract more people to hopefully write this faster than in 10 years. I would hope we have some reasonable, stable using initial codegen for an architecture or two, like let's say RISC-V and PowerPC or ARM or whatnot. Like maybe ARM would make as much. I'm not in love with ARM, but probably ARM64 would make sense. Like some two reasons, like actually, okay, x86 would make sense. Okay, RISC-V and x86 also to test x86 codegen. I would hope, yeah, basically reasonable. I mean, not production ready, like production stable if you know what you're doing, like reasonable stable, not language, like we might like Rust, like constantly change, like basically reasonable first prototype this year, that hopefully we could start for like, yeah, maybe, yeah. Next we will do codegen. So this, of course, that is a totally duct tape implementation, but we need to, like, this is also how I would say Fabrice Billard would do that, except he would, of course, use C, like he probably does most things in C. And actually, C64 logo was first language about logo. Yeah, not a fan of this stuff. Not a fan of logo. Yeah, so the sooner the better, obviously, because then we could do more fun things based on that and replace Lua and so on, right? The garbage collection stuff will not be, I was like, not the super greatest fan of garbage collection. Like, we will see what precisely we will use. If we support garbage collections, that will be next year or whatnot, and that will be implemented in higher level primitives in some core language. Like, so the core language, I decided like to map the core language with static typing, statically and fixed size integer and float typing to the minimal codegen intermediate representation. That will be fully typed, and so any Lua like auto typing will be in the core, probably optional calling library, so that we can also do bootloader, like direct machine firmware bootloader code. I think a language like a totally like my goal would be like really readable, maintainable, most minimal production ready, because like, even Zig became too big. Like stuff, people always like add everything in the kitchen sink, and then you have hundreds of megabytes of like, yeah, what tiny little language, only hundreds of megabytes plus LVM codegen, and that's what I'm doing this. So probably, yeah, 5.5 hours. Basically, I probably should do some other things, answer my business customers. Amazing that more people tuned in. Just what I would hope for. So next is more starting minimal codegen and then building this out, like in every, like more parsing, more AST, more codegen, more optimization and stuff. Every week. That's basically the plan. And as I said, unfortunately, we probably need to do some early advertising to have a summary and attract more people. Maybe I should straight commit this to Git to attract more modern people. That probably would be a good plan. We just need, I mean, we could randomly rename that. Maybe we initially, is there an R2? Like, because I mean, I would use R if there, unfortunately, there's an R lang, of course, which totally sucks for statistical computing. I mean, should we R2? Because nah, R2 Langhamden, R2 Amsterdam, nah. I mean, maybe R, like, I mean, otherwise Pluto Lang, I don't like. I mean, we could also. There's a bloody Pluto Lang, of course. There's a bloody Pluto Lang. Superset of Lua 5.4 was. Yeah, I was like, of course there is. Nah. As the guy who's mostly satisfied with C interest in is happy to hear that. Yeah, I'm happy to hear that. So I mean, of course, it will support object-oriented programming and stuff, like most people do in C anyway. But yeah, so this is not final, right? Like this is also like I probably should make a proper proper document, more so. But like a lot of stuff changed, right? Initially I thought I'd do types like Rust and Zig, but I didn't like it. And initially I thought I'd do let because it's okay. But like this is like use your stuff for like just for some hours, like type some stuff. Like nah, that's annoying. That's like meh. Because my new stuff here was auto and stuff, right? Like auto will be a non-first class. Like the first class native things will only be integer and float points and stuff. Like basically C like low level things. And everything else, including like auto, will be like a proper class. Like this will be struct or class, whatever we will call that. Like this will be struct auto of doing the Lua like thing stuff, right? Probably something, yeah, maybe even a we will see, maybe even a like maybe a header only, always inline for performance things. We will see. I settled to like just by typing examples. It's super annoying to type let all the time, like let type of stuff like colon, like that's like no, it's like why did they do that? Yeah, crazy times. I didn't think in 2025. I thought by 2025 C++ would be amazing, but rustic and kind of like yeah, I need at least some. I was like, I hate this websites of everything is amazing with like how's it even? This website doesn't even look. Yeah, hours. So yeah, hours like what should not be robust. I mean, this is as much. The crazy thing is how much, so many missed opportunities. I mean, sure, I couldn't do anything. I did too much T2 Linux. Obviously, it's crazy that they. I mean, okay, maybe this is. Hey man, you probably should list myself as corporate sponsor. We should do more sponsorship stuff. Like maybe I should also more social. Like, hey, if there's some people out there, like some founder of GitHub or whatnot, Microsoft listening, and want to donate some $10,000, that would be amazing. Going forward, we need more sponsor listing on T2 Linux. I probably should do more social engineering with people of like, hey, people who are millionaires of venture capital, whatnot, things of like who have some $10,000 to spare to fund all this stuff. Yeah, it is what it is. I also thought like until now L4 Linux microkernel would be more mainstream and amazing. That yeah. But don't blame me for not invented here and the 1001 programming language. Like, hey, I tried C++ for 20 years and now all I got is Zig and Rust, which I was like, dude, like why are Rust and Zig so annoying, right? Like, I wish Rust were annoying, but I wish they all were annoying, but they aren't. And they even ruined the great, like basically everything that it's not annoying, like Rust and Cargo, they even ruined X11 by deleting all the vintage stuff. Like 10 years still not Wayland, like half working Wayland, like 90% working Wayland. And as a thank you, they deleted all the vintage acceleration, like too. But it is what it is. Yeah. Yeah, I guess we do this on Git. That would make the most sense. Maybe then, as Pluto is taken, as much as like probably mostly abundant. Are those people still doing? I mean, that's annoying thing. You have a halfway decent name, and of course it's taken. We probably don't use Pluto then. I don't know. Like, is it even like probably mostly dead? Do they do something on GitHub? I mean, that's like with T2. Oh no, they're not dead. They yesterday. Okay, YOLO. Yeah, then probably R2 for now until we have a better name. Like, I'm not the super best with, like, maybe someone comes up with a super amazingly more name. And maybe what is the opposite of Rust? What is the opposite of what is things of, how do we like oxidate and how do we even call that? Similar opposite words. Synonyms for rust: rot, decay, decompose, oxidize. What was the term for inverse? Like dew reduction? Is it reduction? It sounds somewhat right. Hydrate? No, it's probably more reduction, right? Like if oxide, maybe a reduction. I mean, it actually would match to like we reduce stuff to the bare minimum beauty, like to bare minimum beautiful code stuff. Maybe some, but at least a yeah, I mean deoxidized, but I think reduction might be the chemical. Chemical. Any class of reaction with the number of electrons associated with an atom group of atoms is increased. Electrons takes. Wait, what? Reduction? Any? Wait, what? Chemistry reduction was gaining of electrons by one of the atoms involved in the reaction between two chemicals, or due it has been related oxidation. Describes chemical reaction of which atoms have an increase or what? Describes all chemical. It's like Rust naming you. Like, yes, they named it like some mushroom or whatnot, spores of stuff, like, but like due. Describes all chemical which atoms have an increase or decrease in oxidation. An example reduction is when iron reacts. Actually, wait, this is basically we want it, the iron is oxidated and oxygen is reduced. Okay, oxygen is reduced. It's called redox. Reverses that reaction using carbon. Blast furnace reverses that reaction. Carbon monoxide and reducing agent to reducing agent. Okay, so reduction is any increase, and okay, that's yeah. Pills, yeah. Redox would be too confusing. Detox. Detox, yes. De-rust, I don't have a good name. Name also doesn't matter. Schall und Rauch, right? Okay, probably not Pluto, unfortunately, unless they have been done their project. Reduction lang Parse, I don't know yet. If anyone Esperanto persons move away from English and things, maybe we should name our language after some word in the Klingonian Vulcan dictionary. Anyway, that's it for today. I hope you just learned something. If you're new to our stuff, the Patreon was probably pinned. I hope so. Did I not pin? First time chatter. Chat messages. I hope you just learned something. We also have a full news distribution, which is obviously amazing. Where did I click now? My weekly top cheers, where it's even. I don't instantly see where my pinned tweet or not is. Anyway, that's it for today. I hope you just learned something. Let's T2 Linux support thing, right? There are all the links, and actually pin always this one. This is so much more clever to pin. Somehow I always. There you have all the information in one place, how to support us and how to find T2. And we of course have amazing music, so let's see. Some of this latest installation doesn't always instantly play that for some reason. Not really sure what's going on here with that not always playing.
Now they call it brilliant, guess who's getting paid?